I think we are live. I just confirmed with Bob that Zoom and YouTube were connected. So, yeah, there we go. I see you on YouTube, Tom. So I think we're live.
Okay. Sounds good. Why don't we get started? Good morning, everyone. My name is Tom Stahl. I'm the Conservation Recovery Program Manager for the Oregon Department of Fish and Wildlife, and I will be moderating the agenda for this meeting. And normally we like to have these types of meetings in person, but that wasn't possible. So we're doing this on this virtual platform, and we're lucky enough to have some help on that end from Josh Metzler, who is from PSU, and he'll be moderating kind of the technical meeting aspects. And so I'll first hand it over to Josh to kind of get us oriented to using this Zoom meeting. So Josh, thanks.
All right, thanks, Tom. Again, my name is Josh Metzler from Portland State University, providing technical support today. So to get us started, I just want to make sure we're all comfortable with the features that's available on Zoom that we'll likely be using throughout the day. A couple of things. First is the microphone option, mute and unmute. If you look on, if you're on your laptop or computer or your tablet devices, on the top left of your screen, you'll see a microphone icon. You can click that to toggle between mute and unmute. We ask that you please mute yourself during the meeting unless you are making comments or asking questions. Next to it is the video or camera icon. Again, you can click that to toggle on and off. You turn on your video. The video, it's optional. You're more than welcome to turn on your video throughout the meeting or only when you speak. I saw a lot of us had the video turned off yesterday, so it's up to you. A couple more things. Also on the bottom of the screen, you'll see a chat icon. We can use that for asking questions and making comments, but we prefer that you turn on your microphone to make those comments and ask questions, and I'll go over that shortly. But that's available if you need to post anything. Another thing, click on the participants icon. That will open up the panel on the right side with everyone who's logged in. In there, you'll see a raise hand icon. It's a blue hand. We can test that right now if you like. By clicking that, a raise hand icon will show up both next to your, both on your camera view as well as next to your name in the participants list. That'll indicate to me and Tom, who are keeping an eye on the meeting, who has something to say. So right now I think I saw Ryan's hand up, and I'll call out Ryan so that he can turn on his mic and speak. So that's a good way for us to communicate. For those who are calling in today, I see a few phone numbers listed here. For your microphone option on your keypad, you can mute or unmute yourself by entering *6. I think John tested that earlier today, and that worked. So you should be able to test that out right now if you like. You can also use the raise hand feature, even if you're on your mobile phone, by entering *9. That will, on our end, that'll show your raised hand icon. If you have any trouble, do let us know. If your microphone's not working for whatever reason, you don't want to type it in the chat, just go ahead and interrupt us. That'll be okay. And lastly, this meeting is being streamed live on YouTube. Let's see, what else, Tom?
I think that's it.
Great. Well, thanks, everyone. And again, we'll have breaks here and there, or also during the lunch break. I think we will have one. We can coordinate any troubleshooting if you experience any technical issues in the morning. Thanks.
Yeah, and if you are having technical issues, you can also use chat. Josh is monitoring that. Several people had trouble with their microphones yesterday, and Josh worked through that with them. So, okay. Well, again, we appreciate everybody taking the time out to attend this meeting. ODFW is in the process of developing a conservation plan for a number of species in the Rogue South Coast area. We are early in the development of this. We don't have a draft plan yet. We're really building the components to that plan at this point. And that's what we wanted to get your feedback on today. So our objectives today are to really present you with some background information and then have discussions on the habitat-based actions that we are thinking about adding to this plan and get your feedback on those. Let's see. We are only going to be talking about habitat-based actions today. There are other fish management actions and strategies that have been discussed with a stakeholder team that has been identified and that we've been working with the past 6 months. We'll give an overview of what those are towards the end of the meeting. But today we are really just talking about the habitat components of the plan. And for the agenda, we are going to start out with, after I'm done with this introduction here, I'll give an overview of kind of what the plan development looks like, so you have feel for that, where we are and where we're going and your opportunities for input. Then we'll get into some of the background information as far as what the plan contains, where we are with the different species in terms of status now, where we might be in the future with respect to climate change for these populations, then really get into the details of the habitat management strategies and actions. So we will be stopping today during each of those each of those agenda sections for discussion and feedback. Feel free to, at that point, raise your hand on the Zoom meeting or let us know in chat you want to talk, and we'll get you on board. We aren't going to do any introductions in this platform. So the first time you speak, if you could introduce yourself and let us know who you're with, that would be great. So we know, so others know who you are. Let's see. I will be moderating this to make sure we stay on schedule. Yesterday we had plenty of time. So hopefully we'll have a lot of time for discussion and questions. But I will be trying to make sure if things are getting tight to keep us on track. We will be presenting slides or the packet of information which was sent out to you last week on the screen. And for those on the phone, we will try to remember to let you know where we are in the packet if that's up and you have that printed out or available to you. But if anybody's wondering where we are in the packet or need some direction on that, just let us know and or just remind us to let you know where we are, and we'll get that out there. So let's see. Let me check and see if I missed anything. Any questions on kind of the format for the meeting today and what we'll be going over? Okay, well, with that, then I will share my screen and we can get into an overview of kind of the plan development. There we go. So are people able to see my screen okay?
Yes.
Okay, great. So on the left-hand side, we have the steps that are involved in developing and bringing this plan to final approval, which will happen by our commission. They are responsible for adopting and approving these conservation plans. ODFW has been working internally on status assessments and the plan foundations. actually for almost 2 years now. We kicked this off internally in October of 2018, gathering data, doing the current status assessment, and getting into the future status assessment piece, which you'll hear today and which is actually still ongoing pieces of it. So we've been developing things for a while, and you'll see a lot of that today at a pretty high level. Then in February, we started working with a group of stakeholders on more of the fishing related management categories. And a number of those stakeholders are also, and all those stakeholders are also part of the habitat work group, which is what we're doing now. And we will also be meeting with tribes and NOAA fisheries to talk about the management strategies and actions. So we're calling those our partners. These are the groups that we're meeting with to help develop the specific pieces of the plan prior to having a draft of the plan. So we expect to have most of those discussions over in October. The habitat work group which is this meeting is part of, really consists of the meeting yesterday and the meeting today, and a period for comments, which I'll talk about in more detail towards the end of this meeting. And then we will be meeting with tribes and NOAA fisheries, hopefully in October, to go over the components of the plan with them. And so after that, we will be developing the first full draft of the plan. There's no written draft yet, just pieces like you've seen in the packet. That first draft, we're going to be sharing with all the partners to get your feedback on that. So another point of feedback you can provide. We also have all of our plans reviewed by independent scientists. Normally we do that with the public draft, but there's been some discussion about giving them a bit more time. So we may have them review that first draft as well. Once we get that feedback, again, that draft we hope to have out by the end of the year, with about a 6-week turnaround period for comments is our thought. If we feel like we need to hold more meetings after that, we may do that as well. But after we get the feedback and make revisions to the plan, then we'll have a public draft, start a public process with a comment period there and public meetings to really get feedback from the public. Everybody who's been working with us to date on this, all the partners, also certainly welcome to be involved in that stage as well. Once we get feedback from the public, we'll take it to the commission. We're hoping to do that in April, early spring of 2021. But that draft that goes to the commission will be based on comments we've heard during the public part of the process. At that first commission meeting, which will not be decisional, it'll be informational for the commission. That's where we hope to kind of draw lingering concerns, all the support that is out there. So partners, the public, and the commission all provide us feedback at that meeting. Then we, again, go back, make a revision to the plan. Then hopefully in June of 2021, we go back to the commission and most of the issues are worked out, and the commission makes a final decision on approval. And we have a final plan in place. That is the projected timeline here. Certainly things can happen that will change that. For instance, the wildfires actually slow this down on some of the future climate change based assessments that we're doing, and we'll talk more about that today. But things happen, but this is our best guess right now of when this plan might be adopted. So any questions about that? I'm gonna see if, and I cannot right now see the raised hands. So Josh, if you see any, let me know.
Yes, I'm looking at the list right here. I don't see anyone yet. And again, if you're on your phone, enter *9 in your keypad to raise your hand. And if you're having any issue, feel free to just unmute yourself and ask questions.
Okay, not hearing any questions. We're next going to get into some background information, and I will hand it over to Chris Lorian to share his screen and give you some of the background information for the plan and where our current status assessments have landed. So Chris?
Thanks, Tom. So my name is Chris Lorian, and I work in the Conservation and Recovery Program in Salem for ODF&W, and my title is the Native Fish Conservation Coordinator. And a big part of my job is working to develop and implement these conservation plans, like the Rogue South Coast Multi-Species Plan that we're talking about today. So I'm going to give some background that I think will be is important and helpful to understand where we came up with our management strategies and actions. So I'll talk about the planning context for development of this plan, the species and populations that we're covering, and the results of our current status assessment, which is kind of our starting point for understanding what needs to happen with the management and conservation of these species. So I'll start kind of big picture here with our agency mission, which is to protect and enhance Oregon's fish and wildlife and their habitats for use and enjoyment by present and future generations. There's a lot packed into this little phrase, but really a big take home is that we have this responsibility to provide for the utilization of these resources and protect these populations and their habitats in the present, but then also have this really important mission to protect them into the future for future use and enjoyment. So that bedrock of conservation, but also providing for utilization is really where these plans come from. And that's why we call it a conservation and management plan, because there's both conservation and management needs to achieve that mission. So we have a lot of policies to try to help us achieve that mission. But the central one for native fish conservation is the aptly named Native Fish Conservation Policy. And the policy has three main goals, which is to prevent serious depletion of our native fish populations, to maintain and restore naturally produced fish, to provide the substantial ecological, economic, and cultural benefits that they provide to Oregonians, and also to foster and sustain fishing opportunities that are consistent with native fish conservation. So again, we're getting back to this. Naturally produced fish are foundational for both the conservation and fishing opportunity, and that's where the Native Fish Conservation Policy is directing us. And of course, habitat is the foundation for natural production, so that's why we're here today, and that's why this part of the planning process is so important. The Native Fish Conservation Policy lays out in some detail the process for developing conservation plans that will guide management of species. And so I'll just step through the elements that it lays out in the policy and where we're at with each of those. So the first is to identify SMUs and populations. And SMUs are our species management units, which are a collection of populations in a geographic area that share genetic and ecological characteristics. And so we've identified SMUs throughout the state for our native fish. And so we develop a conservation plan specifically for those SMUs. The first step, one of the first steps in that process after we've identified those populations is to identify and assess their current status, where we think the populations are doing right now in terms of their viability, their ability to persist in the future. And we'll talk a little bit more about what that means. The plan calls next for us to develop through a public process a desired status for each of these SMUs, where we want to be with them to provide those benefits that we talked about, cultural and ecological and economic benefits. Identify limiting factors that are causing that gap between current and desired status, and then identify management strategies to address those limiting factors. And that's where we are. That's why that's highlighted in this slide, is that that's where we are today, to talk about these habitat management strategies to address some of the limiting factors that are affecting the populations in this planning area. There's some other planning components of adaptive management, reporting, and impacts to other native fish as well. So it's important to note that we've already developed 2 conservation plans under the Native Fish Conservation Policy for the Rogue South Coast area. One was for spring Chinook, and the other was for fall Chinook. And those plans are in place and have been implemented. And we took a SMU specific approach to those plans. In this case, we're taking a multi-species approach because the planned species, which are cutthroat, trout, coho salmon, and steelhead, share a lot of characteristics and what attributes of what they need in terms of conservation and management. And so we feel like this is a efficient and effective way to provide for the conservation of these species by tackling all 3 of these, or 4 SMUs at once in this multi-species plan. So that's where that's some explanation about where we're at with these. So I'll get a little bit more into the species and populations that we're going to cover. So the first is the Winter Steelhead Species Management Unit for the Rogue South Coast area. We've identified 10 populations of winter steelhead. These are independent populations that we feel like are on their own trajectory, have enough individuals, and are functioning as an independent unit. There's 4 in the Rogue and 6 along the coast. And in your packet, there's some additional details about the smaller populations that occur in direct ocean tributaries that are very small basins, and also some additional details about the North Fork Smith, which is kind of a special case because most of that population is in California. But in the Rogue, we have 4 populations that we've identified. And a really important thing about winter steelhead is they're abundant and widespread in this planning area. They're one of the most important species that are common in the streams here. They have a tremendous amount of life history diversity, both in terms of how much time they spend in freshwater and in the ocean. So they can spend 1 to 3 years in freshwater, have different ocean residence time up to 3 years, and can spawn multiple times. We end up with fish of lots of different ages that are part of this population. They're also really special globally, nationally and globally, in terms of a special life history. They exhibit called the half pounder. That is a fish that returns from the ocean after just a few months, comes back into, migrates out to the ocean, comes back in after a few months, overwinters in freshwater, and then migrates back out to the ocean to later return as an adult steelhead. And this life history is only seen in a few populations in Southern Oregon and Northern California, and a few places in Russia, in the Western Pacific. And so it's really a special thing, and also provides a unique fishing opportunity in the Rogue. The coastal populations are more similar to our other coastal populations of winter steelhead, but they don't exhibit that life history. It's unique to the Rogue. So the next SMU is summer steelhead. In this case, we just have 2 populations that are in the interior Rogue. And summer steelhead are similar to winter steelhead in that they have all this life history diversity about how much time they spend in freshwater in the ocean. And nearly all of the summer steelhead, when we've done previous studies, appear to go through that half pounder life history. So it's even more common. It's much more common in summer steelhead than in the winter steelhead. And summer steelhead provide incredible fishing opportunities in the Rogue and are really a treasure of this area to protect. Coho salmon is the next one. The picture with coho salmon is a little more complicated, but for today's discussion, that we've got an interior Rogue stratum that has 3 populations in the Illinois, the Middle Rogue Applegate, and the Upper Rogue. On the coast, we have just one independent population and several dependent populations. And there's more information about that in your packet if you want to dig into that. Coho are different than steelhead in the sense that they have a much more fixed life history. Almost all fish spend 1 year in fresh water before migrating out to the ocean. And they generally spend 18 months in the ocean. All the adults do. There are some fish that return earlier as jacks, but they're on a much more fixed life history, and they also have more specific habitat requirements. They really like low gradient streams with a lot of structure and are really more of a tributary fish, whereas steelhead tend to use the whole, what we sometimes call the riverscape, all the streams up to large rivers. So coho tend to be much more focused in the tribs and specific kinds of tribs that have a more particular kinds of habitats that they need. And you can see on the right-hand side of coho at the beginning and end of its life cycle there. And last but not least are coastal cutthroat trout, which are also distributed throughout this planning area. We've identified the populations to be consistent with steelhead for management purposes, but it is important to note that coastal cutthroat trout can have pretty complex structure because they can exist as isolated populations above waterfalls. They don't have to migrate to the ocean. They can stay in freshwater their whole life. They can migrate to large rivers to kind of rear and get to a larger adult size, and then some of them migrate to the ocean as sea-run cutthroat trout. So they have a tremendous amount of diversity, and there's some populations in the Rogue above waterfalls that are really highly differentiated, smaller populations. But for the purpose of this plan, we're thinking about these 10 populations that are similar to the ones we had they're the same boundaries that we had for steelhead. So now I'll quickly go over our current status assessment and this is represented over a year of work, but I'm gonna have to boil it down to just a few minutes here, but we will have time for a few questions if people want to dig into it, and there is more information available about this in your packet. So the status assessment approach for these populations was to assess all the independent populations using viable salmonid population parameters. And these are basically parameters that are associated with viability, which is the ability to persist now and into the future. And those parameters are abundance, or how many fish are out there, either adults or juveniles. Productivity, which is the ability of fish to replace themselves in the next generation and produce offspring and adults in the next generation. Spatial structure, which is the distribution of fish across the landscape. And diversity, which gets back to some of those life history characteristics that I was talking about before. And these are all parameters that contribute to fish being resilient and able to persist over time, given the natural variability in environmental conditions and all the other challenges they face and these are all things that help the fish persist in the face of those. So we took those parameters and we determined a viability risk for all the populations in strata. And so we have 2 strata in general, one for the Rogue and one for the coast. When we say viability risk, we're talking about how well these fish are going to be able to persist into the future. High viability risk then would mean that we're concerned about their ability to persist into the future. Low viability risk means that the populations are relatively secure and we feel like they're going to be able to persist and provide all those other ecological benefits and cultural benefits for fisheries and other things like that. So based on that, we determined an SMU status for each of these SMUs, and I will talk about that next. So in your packet, there's a pretty complicated table that shows all the scoring that went into the status assessment. And so we've got a variety of parameters in that blue box that we assessed for each of those categories that we talked about for those viable salmonid population parameters. And so on the right-hand side, you've got all the populations and SMUs. And then in that blue box, we've got lots of scores that came up. The size of those boxes depends on whether we had population-specific data or stratum level data. And A 1 indicates low viability risk, or an indicator of low viability risk, and a 5 would be the indication of the highest risk or concern. So we took all those scores, rolled them up into that box that's the orange box for viability risk. And those population scores, again, are on a scale from 1 to 5, with 5 being a high concern or high viability risk, and low being low viability risk, the ones we think are more secure. And we're going to have the highest, ability to persist and into the future. So then in the red box, we've got some additional scores that were about our confidence in our viability results based on recent trend data or the completeness of how much data we had for specific populations or strata. And then finally, in the far right hand side of that box, you'll see the actual status of the SMUs that we assigned. And I'll talk about that more on the next slide here. So the final kind of status categories that we place these fish in, you can see on the bottom of this slide, there's the SMU status categories that fish could have fallen into, which range from strong all the way to endangered. The threatened and endangered categories in this are based on state level criteria that shouldn't be confused with those designations under the Endangered Species Act. But in any case, you can still see that anything on the left-hand side is where we want fish to be in those strong guarded categories. On the right-hand side are fish that would be indications that we have very serious concerns. So winter steelhead and cutthroat trout both came out in our strong guarded category, which basically means they're abundant and widely distributed across the landscape. We have low viability concerns. The guarded part comes in because we may not have complete information, certainly as much information as we would like to have for some of those populations, or because of some trend data that might suggest additional risk. For summer steelhead came out in the sensitive category, which again, which is a little bit different in the sense that we're more concerned about these populations, but it may not be because of a viability risk, but just because of their inherent vulnerability because of their smaller distribution. And as Dan Van Dyke likes to say, our district biologist in the Upper Rogue, that summer steelhead like to live where people like to live. And so they're just inherently more threats to their habitat, whereas winter steelhead have anchor habitats in really undeveloped watersheds where they have relatively secure habitats that are not really at risk in those places. Finally, coho salmon fell into the sensitive critical category that is an indication, that they are going to need more proactive management, and we have real concerns about them. Although we don't have short-term viability concerns, we definitely they need to be moved into an improvement in status that will feel secure going into the future. So that's where coho salmon landed. It's also important to note that there are Coho Salmon SMU is part of a larger ESU, which is an evolutionarily significant unit. That's the federal designation for the groups of populations for listing under the Endangered Species Act. And that larger ESU, the Southern Oregon, Northern California Coast Coho ESU, is listed as threatened under the Endangered Species Act. And so these coho salmon populations in this area have a federal recovery plan that's in place to guide conservation. So it's important to keep that in mind. Let's see, I know that's a lot of material, but I think that's what I've got, and we can take questions.
Any questions from anybody about the species being covered, what the current status is? Steve, looks like you have your hand raised. Remember to take yourself off mute and introduce yourself, please.
I'm not sure. Somehow I don't see the microphone icon next to Steve's name. Hey Steve, I'm gonna try to unmute you from my end.
Hey, Josh, I did notice that Steve has two entries on here.
Let's see. Oh yeah, so he's probably on his phone. Hey Steve, if you hear me, let's see, on your keypad on your phone, enter *6. I'm guessing he's using his phone for audio and then using his computer for viewing the presentation. Okay, Steve, try it again. Okay, maybe Tom, at this time, it might be best to have him just type in his question or comment.
That sounds good. Steve,
Yeah.
So we're still not able to hear you. If you're able to type in your question or comment, I can repeat it to the group.
And we can work on the troubleshooting during the break. That's coming up soon.
Okay.
Sorry, Steve.
Okay, any other questions? Hearing none, we are going to move into.
Hey, Tom, I'm sorry to interrupt. Steve, your mic is on now on your phone. Go ahead and speak.
Yeah, I was all screwed up there. I was rather than watching, so I'm sorry, folks.
That's okay.
I guess you didn't get anything that I said there. So,
no.
It was my concern was Coho and the makeups of the geographic makeups of the stream. You take you've stated that Coho like slow-moving water, and which would take low gradient, but some of the streams like the Illinois or the Elk River are narrow, steep, gradient streams with all the tributaries running in at a very steep angle, and so trying to increase coho populations and habitat that is not suitable to them seems like a pushing the rock uphill, and using that to hold back other populations maybe. I don't think the feds did a very good job of looking at suitable habitat before saying that coho should have big populations in the Chetco or the Illinois or even the Elk River, but that's just an observation.
Thank you, Steve.
Thanks, Steve. I think that's a really important point when we're having this discussion, is that coho really do have different habitat requirements than steelhead and some of these other plant species. And so their habitats in this area are naturally more limited, and that just increases the importance of protecting those places where there are coho strongholds, especially in the interior rogue. So that's an important part of thinking about habitat planning in this plan.
Okay. Well, why don't we move on to the next agenda item, which is climate change risk evaluation. We just heard from Chris kind of where we think fish populations are currently. Now we're going to hear from Dr. Sean Clements and others where we think these fish might be in the future, or what's coming at them with respect to habitat. So with that, Sean?
Thanks, Tom. Yeah, so Sean Clements, I'm the Senior Policy Analyst in Fish Division in Salem. And I think we're going to talk a bit about the climate and ocean changes that we're expecting here in the Rogue South Coast area over the coming century, and then a little bit about how that information is used in planning. Should be no surprise to anyone that there are changes going on. I think there's been a number of events over the last decade that make it self-evident. But in terms of fish and wildlife, the primary impact we're seeing is this undermining of the ability of habitat to support the fish. And that's through a range of impacts to the streams, including stream flow and stream temperatures. We're going to talk a bit about those today. And the reason we're bringing it up today is because mitigating these impacts through actions on habitat, either protection, restoration, or enhancement, is going to be one of the key management strategies for reducing the impacts of climate and ocean change on these species. So back in June, ODFW Commission adopted a climate and ocean change policy. This was intended, the policy was kind of a high-level guidance to the department to help us prepare and respond appropriately to the impacts of changing climate and ocean, so that we can continue to use and enjoy the species and that they can continue to have a home here. The policy itself had several goals. The goals that are relevant to this group are first and second, and a little bit of the third, which is understanding and acting on the risks and opportunities. And we're going to hear today what those risks are, but also what the opportunities are to mitigate some of those risks. And then in terms of addressing some of those, it's providing leadership on a coordinated statewide and regional response, and then just increasing public awareness about some of the impacts that we are seeing and are likely to see. In terms of implementing the policy, it lays out 6 ways that the department's going to go about doing that. And the one relevant to today is that we're going to incorporate key principles in that policy into a new plan, and the new plan being this Rogue South Coast Management and Conservation Plan. Just wanted to highlight some of the key principles that we will be including or referencing during development of this plan. There's 4 of them here. First one being that conservation is foundational. Conservation, a solid base of these species, is kind of the foundation on which we can play. But recognizing that, there's also opportunity to scale use of the resource depending on the health of the population. The other key principle is that we need to consider the future conditions. The past is no longer a good predictor of the future, and we need to understand where things might be headed so that we can adopt strategies that are likely to result in resilient populations in the future. And that leads into the 4th one, which is making sure those strategies are robust to some uncertainty. Although we have a general, pretty good idea of the trajectory and what the endpoints look like, there's uncertainty in the timing of those impacts, the spatial variability in those impacts, and then the ability of the animals themselves to adapt. And then the last one here, which is really key for today, is direction in the policy to protect and enhance the most important habitat. So you're going to see several maps throughout the day showing the impacts that we're expecting, and you should take home from that a lot of spatial variability. And so it's identifying those habitats that are going to be most impacted and then also most resilient, and using that to help identify where the action should occur. Just kind of an orientation, we're going to talk a bit about the changes that are coming to the region. Then myself and Kara and Lefton are going to talk about some of the analyses we're doing to understand how they might impact fish, and then talk a little bit about how we use this information in planning. And just on the right there, you can see kind of a graphic showing the expectation for climate in Medford by 2100. It's likely going to look something like Southern California. So we're going to start off talking about some of the changes that we're expecting on the inland side, and then move into the ocean. For all of these analyses, we used, you have to pick a scenario, a climate scenario, emission scenario that you want to use to understand what changes might be coming. There's currently 4 scenarios that are used by climate scientists. They're called representative concentration pathway scenarios, and they essentially amount to, by 2100, how much warming is going to hit a square meter of Earth. And they range from 2.6 to 8.5, 2.6 being less warming, 8.5 being more warming. And we use the 8.5 scenario. That kind of represents a worst case scenario for planning. But also at the moment, unfortunately, it's the most likely scenario. So everything you're going to see here today is on an 8.5 scenario, projecting forward to the period 2070 to 2099. So summers in this area have been warming over the last half century. I think since 1970, there's been about a 4-degree increase in summer, average summer temperatures in Medford. And that's going to continue. We're looking at around a 9 to 13 degree Fahrenheit increase in the Medford area over the next, before 2100. We're also looking at a doubling of hot days, which are around, which is greater than 86 degrees Fahrenheit. And these changes are, if you look across the Rogue South Coast planning area, you can see, again, that spatial variability I was talking about, where the coast is going to experience less warming, and most of the warming is going to occur on the interior and at elevation. Most of the models are projecting a slight increase in warming at higher elevations. Again, this warming is a result of the greenhouse gases, carbon dioxide, methane being trapped in the atmosphere and kind of holding the heat back. We're also going to see warming in winter, which has a lot of implications for the precipitation that we're going to get into in a minute. Again, same pattern that we have more warming in the interior, less warming on the coast, and more warming at higher elevations in the winter. And this all plays into having longer growing seasons, changes the precipitation patterns, and it has impacts on the stream flow. So getting into precipitation, in summer, this area is one of the driest in the country. I think there's something like 5% of annual precipitation falls in summer. So although you're seeing some pretty significant percentage changes, particularly on the coast, the absolute change in precipitation is pretty minimal. And this is likely to have little impact on summer flows, this kind of change in summer precip, because most of that flow is coming from shallow groundwater. Winter precipitation, we're likely to see more winter precipitation throughout the basin, tended to be concentrated on the coast and at higher elevations. And we're looking at around a 14 to 15% increase in those areas. Unfortunately, a lot of this increased precipitation is going to be offset by increased evapotranspiration because of the warming temperatures, longer growing seasons. We're going to get increased evapotranspiration. So in general, throughout the basin, on an annual basis, we're looking at likely a net water loss. The other thing that's going to happen as a result of those warming temperatures, and even though we're getting more precipitation in winter, more of that's going to fall as rain and less as snow. So likely projections are for snowpack to generally be absent across the basin by 2100. Looking at some pretty significant declines there, upwards of 100%. And again, that's going to have impacts on the stream flow and stream temperature. So getting into the things that matter to fish, which is, what's the conditions in the stream in terms of stream flow and stream temperature. I'm going to talk a little bit first about the likely impacts to stream flow. This is a picture of Deer Creek nearby down there. A lot of these creeks naturally run dry in summer, and you're going to see some projections looking at how that might change in the future. So looking first at change in summer natural flow. This is a projection from the variable infiltration capacity model that was developed at University of Washington. And they've done some downscale model projections for the Western US. So this is looking at the what proportion of average summer flow we expect in the future relative to what we've seen historically. So the green areas, you're seeing a really minor change, kind of like a 10% decrease in average summer flows. Yellow areas, it's around a 20 to 30% decrease in average summer flows. This model is good for kind of looking at a general pattern of average flows, but it doesn't do a very good job at looking at the the really low flows. For that, which is where a lot of our concern lies, is those really low flows that create passage barriers and temperature problems, fragmentation, etc. For that, we're looking at developing other models to get at the low flow questions. But for now, this is kind of the overall picture, some slight changes in some areas and minimal changes in others. Looking at stream drying, I mentioned earlier that a lot of the streams in this, and especially headwater streams in this area, run dry in summer naturally. So there's a lot of existing variability in that throughout the basin. This is Prosper was a model developed by USGS, looks at the probability of stream flow permanence. So if you look on this graph, blue areas are places where there's high likelihood of streams staying wet year round. And then the yellow and red areas are streams that are more likely to go dry during summer. And that probability is like, if you're looking at the yellow areas, that's about a 50-50 probability that it's going to go dry. This model is a little squirrely in this area. There was not a lot of data points that went into it. So BLM, Forest Service, and others are looking to beef that up a little bit. But I think it gives a good general picture of the areas that are most likely to go dry. What we did is kind of compare, look at this data in light of which areas are likely to be more affected than others as a result of climate change. And to do that, we compared the average time period, which was like 2006 through 2017, to the drought year in 2015 to see how the drought year changed the kind of pattern of drying. And essentially the red areas are where you have a much higher probability during a drought year of drying. And the green areas are where you see little change in probability of drying during a drought year. And on the left there, you can see some of the variability we're seeing in the basin, and that the Middle Oregon Applegate during drought years, there's a much higher probability of streams going dry than in Hunter Creek. And so this kind of information can help guide where we might want to take habitat actions. The other side of this is looking at the impacts to stream temperatures. Stream temperatures are affected by both flow and ambient air temperature and the amount of energy hitting the stream. So a lot goes into that. This is a model that was the Norwest stream temperature data set that was put together by the Forest Service in collaboration with others. It's a kind of a Northwest effort to map stream temperatures across the area. They've also done some downscale projections looking forward to 2100. And this is the kind of results of that. So we're looking at what temperature change we're expecting in each of these stream reaches by 2100. So the reds are around a 2 to 2.5 degree Celsius increase, and the blues are a 1 to 1.6 degree Celsius increase. So increases everywhere, but some areas are more impacted than others. Again, main stems, lower areas are more impacted. And then particularly you can see in the Middle Rogue Applegate again, and parts of the Upper Rogue below the dam there are more impacted than other areas. And this comes out in some of the data that we've calculated. So for each of these data sets, we looked at what the changes are likely to be within the distribution of each of the species within each population. So for Middle Oregon Applegate steelhead, we're seeing like a 48% increase in unsuitable conditions, whereas for Hunter Creek, it's kind of status quo. So that variability exists across the landscape, and we can use it to help guide where we take actions. Moving on to extreme events, this is another projection as a result of climate change that we're going to see more of these extreme events. Looking at large storm events, the projections on that are a little squirrely again for this region. Generally, the projection is for a 20% increase in atmospheric river events, which lead to these big storms that historically have dumped a lot of snow, rain, and led to flooding. But it's really uncertain. I think there's a lot of uncertainty around the frequency and magnitude of those events, depending on which model we look at. Where there is more certainty is in the occurrence of drought. which we know can have a significant impact on the species down here. This is a projection from NASA just showing soil moisture content forward to 2100. And in another NASA study, the likelihood of a mega drought, which is a 35-year plus drought, by the end of the century was about 20 to 50% in this region. The likelihood of an 11-year drought was around 40 to 50%. So it's pretty high probability that we're going to be looking at a long-term, fairly major drought in this area in the coming years. Switching on to the marine zone, a lot of changes expected here as well. We're looking at a warmer ocean. Since about the 1880s in general, we've seen the global ocean temperature increase pretty significantly. And projecting forward, this is data from National Marine Fisheries Service, or NOAA. We're looking at more warming in the ocean. In the area that we're interested in, I'll use my cursor, just down here in the southern part of Oregon, looking at around a 2.4 to 2.8 degrees Celsius increase in annual sea surface temperatures. And these projections don't work well in the nearshore zone, which is pretty dynamic. So I'd consider like offshore 10 miles and out in the open ocean. These are kind of the general projections. And you can see there's a pattern of increased warming as you go north. So in this area up here, which is where a lot of the steelhead kind of migrate to, there's increased warming relative to the areas off the coast, which is where the coho and cutthroat are feeding. Again, these projections likely are a bit of an underestimate. Most recent studies are showing that the ocean is warming faster than the models are predicting. And there was just one released 2 days ago that showed increased stratification at a higher rate than we were expecting. So I think the take home is that we're going to have a warmer ocean. The other side of that is that in addition to average warming, there's going to be this 20 to 50-fold increase in marine heat wave incidents. And I think folks probably recall the famous blob of 2013-15, which occurred in the Northeast Pacific, and reshaped a lot of the food webs there and had kind of lasting impacts on salmon steelhead returns for many years. Ocean acidification is also one of the primary impacts of climate ocean change. In addition to changing air temperatures, that carbon dioxide is largely sucked up by the ocean, where through a series of chemical reactions it results in acidification. And so that blue line is just showing kind of the correlation between increasing atmospheric carbon dioxide and decreasing ocean pH. This is data taken off Hawaii. In the North Pacific, in the areas that these fish are feeding in, we're going to see an increase in annual surface pH. And so on the left side, you're looking at the actual pH values that they're projecting for 2100. So it's around 7.8, 7.9 in that area. Then on the right side, you're looking at the change between current and the future. And so looking at around a 0.26 to 0.3 decrease in surface pH annually. And this again is in the open ocean. These models don't do well in the nearshore area because of the dynamic nature of the currents, but they do a pretty good job offshore. And these changes, even though they might seem small, this is logarithmic scale, so they're pretty significant. And we're already seeing impacts to some of the animals at the base of the food chain here. I did talk a bit about the nearshore zone. This is data from OSU, Francis Chan and co. They've been monitoring nearshore pH for a number of years now and are showing that this zone has just a ton of variability spatially and temporally. And so that kind of colored image on the right is showing areas of low pH in the red and areas of higher pH in the blue. And you can see it's kind of a longitudinal scale or latitudinal scale from down Southern California up to Northern Oregon. And in Northern Oregon, in the months of July 2013, there was a particularly acidic patch of water up by Nehalem whereas in other parts of the coast, it was certainly more normal conditions. And so I think keep this kind of variability in mind when you think about the opportunities these species have to move around and find areas that are suitable. Last thing I wanted to talk about today in terms of the impacts of the marine environment is upwelling. Upwelling is the thing that supports some of the most productive fisheries we have. Kind of results from that, those winds that run along the shoreline and displace the water at the surface out to the open ocean and bring up the cold, deep water from the ocean. And that cold, deep water has a lot of nutrients and supports a lot of the food web that we see out there. Where projections are for some changes in that upwelling structure. It's an incredibly complicated phenomenon to model, so they're just getting to grips with it. But in general, they're projecting slight increase in intensity of upwelling in the March-April period and a slight decrease in the summer period. And so just look at that box on the right there in the red kind of rectangle. That's the area around the Rogue South Coast Ocean. And the blue area in the summer there is showing slight decrease in intensity of upwelling, and the yellow in the March period kind of right here showing an increase in intensity of upwelling. The interesting thing is that the most recent studies show that there's going to be limited near-term impact or limited near-term changes as a result of climate ocean change on this upwelling. And they don't actually detect a signal until around 2100. So again, in this upper panel, you're seeing a slight decrease in intensity in the July-September period, an increase in intensity in the April period, but in the lower panel, that signal isn't detected until 2100 for this northern zone. So we're evidently some ways out from seeing a change in that upwelling pattern, which is a good thing. I think even when it does hit, if the current projections are accurate, it likely won't have a significant impact on food webs. So I know that a lot of that sounds kind of like the apocalypse, but I hope there is a lot in there for folks to look at the spatial variability that we're seeing. And also I think it's important to keep in mind that when we look at some of those changes and the magnitude of change we're expecting, that in many cases they can be almost entirely offset by management, and some of the management we're going to talk about today, which is flow and habitat restoration. So just as an example of that, if we look at some of those temperature changes we're expecting in the streams, around at the worst 2.4 to 2.5 degrees Celsius, and then we look at what kind of changes, habitat changes we could do to mitigate that. There was a study done in the John Day Basin, just over the hill, where they kind of ran a bunch of management scenarios through a heat source model and looked at the relative impact of increasing air temperature versus shade versus increased flow. And so a 4-degree increase in air temperatures results in a 1.4 degree increase in daily max and mean temperature in the stream. Whereas if you manage the system using shade, riparian shading, an increase from 7% shade to 79% shade can result in a 7.8 degree decrease in daily max and a 4.5 degree decrease in daily min, both of which are well in excess of what the projection is for an increase in stream temperature as a result of that air temperature warming. So I think this highlights that, and I think we see similar things, not to the same extent, but with flow restoration. Increased flow volumes can also help with stream temperatures and also certainly help with passage and avoiding fragmentation. So there's a lot of actions that we can take that can likely wholly mitigate for the changes we're expecting inland at least. So we're going to talk a bit now about how some of these changes might impact fish. There's been several analyses being performed by the folks in Corvallis to look at how these changes might impact. And I think Karen Lefton and Matt Falsey have been working on one, and I think Kara's going to talk about that now.
Sean and Kara, maybe we can take here a break to ask if anybody has any questions. There's a lot to digest for people. So why don't we open it up to questions here for Sean before Kara presents the work that she and Matt have been doing. Any questions on kind of the climate change impacts and how this area will be affected?
Hey, Rich, I saw a hand up for a moment. Yeah. Go ahead and unmute yourself. You can do that by clicking the microphone icon on the bottom left of your screen, Rich. There you go.
Hey, can you hear me?
Yep.
Okay, well, it's a simple question. Eli Asarian has analyzed stream temperatures in the Klamath Basin intensively, looked at 1 million data points and came up with some increases that are obviously from climate change. So have we done the same thing in the Rogue? Have we actually looked at empirical data? I mean, there's tons of stream temperature data. Have we looked at that to see what the actual stream temperatures are in some of our tributaries? Modeling's good, but if we got real data, that's even better.
Yeah, so and Kara can jump in too. She's our stream temperature expert. But the data we showed was derived from empirical stream data that was collected in the Rogue and then filled in with a spatial statistical network. So what you're seeing there was the empirical data and then projected forward with a climate scenario. There's also been other analyses that have looked at historical changes in stream temperature in the area. I think can't recall what the results of those were, but yeah, short answer is yes, that empirical data has been looked at, although I'm sure there's more that we could get out of it. Kara, do you want to add anything?
Yeah, I was going to say that there is a lot of people measuring and collecting stream temperature data. It's just not well coordinated across the landscape. And so in general, folks are doing it for very particular projects and don't necessarily, monitor year round or in a long-term sense. And so we've been working with people down many of the watershed councils and soil and watershed conservation districts and the district, ODFW district, to kind of try and collate some of that data and figure out who's collecting it and where we can put out more thermistors to get as much information as possible, because we recognize that while the Norwest data is super useful, we need to start getting more current information.
Any other questions? Okay, sorry to interrupt you guys. Kara, why don't you take it away? Thank you.
Sure. Everybody see my screen?
Yes.
Okay. So today I'm going to talk a little bit about some modeling that we've just sort of started with the juvenile steelhead abundance data set that the Western Oregon Stream Project, Western Oregon, the snorkeling project that is now Aquatic Inventories Project, has been collecting for many, many years down there in a spatially explicit way over time and space. And so we had developed some species distribution models for coho and for steelhead and for cutthroat, but we sort of had excluded the time component because it makes things a lot more challenging. But in this, we wanted to incorporate time. So I'm just going to show some very preliminary results of what we're trying to do with these data. And so overall, our goal is to take a little more of an empirical approach to understanding how these abundances vary across time and space, and given particular geomorphic and climate variables. So we were really intentional about the variables that we chose. Ultimately, we want to be able to identify distribution shifts through time and through space. We're going to try and do that initially retrospectively, and then be able to use that model to predict distribution shifts under climate projections. And so all the data that the climate data that is going into this has built, they have already built in, a future climate projections into these data. So that was really important that we selected data that had that already. And then ultimately, this is going to be able to aid, in how we manage and conserve these species as we move into the future. So all the analyses were sort of done, were done within, the coastal and rogue stratum. And we were really intentional on making sure that there was that distinction, given that there are really different climate signatures in these two basins and across the South Coast in general. So I just want to show a little, this is the steelhead abundance. It's going to move through time, starting at 2002 to 2018. These are the data that we use. So the red dots are, no data, no steelhead were observed in the year that they were surveyed. And then, the bright blue are larger abundances. So you can sort of see the legend up there at top. And so these are the data that we used as the response variable in the model, the count of the steelhead. And then we also used occurrence as well. So we sort of developed a model that kind of uses both sets of information. And so I just wanted to show just a sort of a different view of how the information is distributed through the stratum and across time. And so the pink is the coast and the greenish blue is the rogue. So you can sort of see that distribution through time. So like most ecological data, and specifically species count data, it does not have a normal distribution. So we had to get a little creative and think a little bit outside the box in how we were going to model these data, particularly given our objective of looking at shifts through time. So I'm not going to dig into that. I'm happy to talk to folks about that. But mostly what I want to talk about is sort of the predictor variables that we're thinking about and some very preliminary results from that modeling efforts. So like I said before, we chose a series of geomorphic variables and climate variables as inputs into this model. One thing that we did that was also intentional was that we wanted to sort of separate out space and time to see what was sort of driving these counts, which process was sort of driving them. So what we did was, for example, for total winter precipitation, we summarized across years. So at an individual site, you'd have the same value through time. So in this graph up here, the spatial graph, you can see there's 3 different sites here. But they all have the same value through time. They're different values because they're different sites, but they're the same through time. Contrast that with the temporal portion where we took that same variable, total winter precipitation, we summarized across all the sites within an individual year. So you can see here on the x-axis a bunch of sites that all have the same value for 2018. And the goal was to see whether or not we could pick up signals through space and through time separately. So I'm just going to show a couple of the results, a couple slides that show some of the results that we found. So we used one of the variables that we used was called distance from ocean, and it's the site distance to the outlet to the mouth. And this, what we found was abundance is changing with increases in site distance from the ocean. That makes sense. The changes vary, and I'm not going to get into that because we're still sort of trying to process what it all means. Second thing was abundance increasing as gradient of site increases. This makes sense given steelhead's propensity sort of to move into higher gradient areas. We found that abundance decreases as floodplain width increases. We looked at summer mean temperature, and this was influenced. We found that abundance is influenced by the distribution of summer temperatures, decreasing as temperatures increase. And this was really consistent across all the candidate models that we looked at. Similarly, when we look at the temporal piece, the same pattern emerged. So decreasing abundance with an increase in temperature. And then finally, total winter precipitation in a spatial sense is continuing to come up in the top models. and it is clearly influencing abundance and the distribution throughout this area. And so we're still trying to understand what that means, and especially as we project into the future. So our next steps are really to continue to explore these results, and then eventually, once we get the final model, we will predict to unsampled locations, and then that will give us, a landscape of retrospectively where places where we haven't sampled within those years, those 2002 through 2018, and then we'll predict using climate projections for summer temperature and winter precip, the variables that appeared in the top models. And that's all.
Thanks, Kara. Any questions for Kara before we move back to Sean? Rich?
Yeah, the first slide you show up, just eyeballing it, you're comparing the rogue with the other basins, just eyeballing that thing. It looks like there's been a substantial decline since about 2012, 2013. So I'm wondering if your analysis, is it showing that? I mean, that's a temporal thing, but is it showing that you're getting a signal from those 8 years where it looks like the numbers were decreasing?
Yeah, we are getting a signal, and as we've been sampling down there, we've noticed a pretty steep decline, particularly in the interior rogue. And yeah, and that's a huge reason why we're doing this work. So yeah, it does show up.
Yeah, well, I've got a follow-up question for
Sure.
Chris. Wouldn't that affect your viability analysis or whatever you're doing? I mean, how can you say summer steelhead they're sensitive? It sounds like they may be bumping into a lower category now if we start looking at this analysis of temperature changes on juvenile production.
Well, I know this question was for Chris, but I want to just point out that this is summer and winter. So these are juvenile fish, so we can't distinguish between the runs. I just want to make that comment, Chris.
Yeah, well, the summer runs are in the interior. We know that. They're
right.
the one. That's where we're getting the rubber's hitting the road there in the interior basins.
Well, we also have to remember that it's about presence or absence in the locations where we survey these juvenile fish, which are in wadable streams. So it's not picking up presence, absence in the larger streams. We've talked about this before, where steelhead may be moving out of some areas and into others. So it's really about presence, absence, where we're sampling. And we did have, Chris, if you want to talk about the status assessment and how that was taken into account, juvenile information.
Yeah, I guess I would have a couple comments about the patterns that you see there. One of them is that, like Tom was saying and Kara, that this is, we can't identify these juvenile steelhead to summer or winter life history or run type. So that's a complication with trying to tease apart any of this stuff and how it relates to the status of those SMUs. I would also note that you kind of see a cycling pattern in there where it was increasing in the early part of the period and then has decreased over the last 8 years, but we don't have data going back very long. So we don't really know what that cycling is related to. And that's part of the goals of this modeling, is try to understand the underlying factors that are driving these cycles in abundance. So we can understand kind of whether they're climate driven, flow or temperature driven, or whether, and that'll give us a much better understanding of what's, how these populations are functioning. So I think that's an important outcome of this modeling exercise and what we're doing there, in addition to being able to kind of look into the future. So I'm hoping that we'll get a better understanding that'll come out of that, Rich. And I think that'll inform future kind of understanding and adaptive management when we're thinking about how to manage these populations.
And juvenile abundance trend was used in our current status assessment. That certainly contributed to the as Chris mentioned when he talked about that, the guarded outcome for winter steelhead. Okay, Steve, you have a question.
Yes, can you hear me?
Yes, we can.
Okay, good. One of the things when I look at this, there's a it's complicated, you know, and it looks like a lot of work went into it. But in 2005, there was a toxic blue algae bloom identified on Lost Creek Lake, and it's I'm not probably not going to say this, but it's a cyanobacteria, you know, and which is actually a bacteria, not algae, you know, and it's toxic to fish, especially ones that are not migrating in and out of the stream, but are you know, holding over a year, or and I would think it would address the juveniles quite heavily. Has anything been overlaid with the toxic blue-green algae bloom that's now going on 6 months a year on Lost Creek Lake? That's it.
I was not aware of that. And so we have not overlaid any specific water quality data other than stream temperature. I will look into that though. Thanks for that.
Okay, Kelly.
Hi, can you guys hear me?
We can. Good morning.
Morning. Thanks, Ryan, for helping me figure out how to raise my hand. Much appreciated. I just had a quick question for you, Kara. You said that from your results, the abundance decreased as floodplain width increased, which seems very counterintuitive to me. Because if you have, you know, more floodplain, I would think you would have more off-channel rearing habitat and those pockets with more hyporheic zones. So is there a specific explanation for that?
So like I said, some of the results that we're finding are interesting and are making me think that we need some additional moderator variables. It is also a function of how we sample on the landscape. And as Tom mentioned, our sampling is in, you know, wadable streams, so they tend to be a bit smaller. So that was a surprising result for us as well, for me as well. And so I think, you know, so I'm considering additional variables that could sort of help me and understand why that result is happening.
Okay, thank you.
Any other questions? Okay, thank you very much, Kara. Sean, back to you.
Okay, here. Yeah, so Kara gave one example of an analysis that we're doing to understand how those changes might impact fish. A lot more to come on that front in the next couple of months here. But one of the other things we're doing at the moment is this climate vulnerability assessment. In 2019, Lisa Crozier from National Marine Fisheries Service and a suite of co-authors published a climate vulnerability assessment for ESA listed salmonids on the coast here, which included this area. They actually assessed the vulnerability of coast coho or swamp coho. We're using that same framework with some modifications to assess the relative vulnerability among the plant populations. So the summer winter steelhead, cutthroat, and coho. This assessment's currently ongoing. Vulnerability is typically looked at as a function of three parameters, one being exposure. So are the animals in a location where they're likely to experience changes? And you saw in some of those maps that some of those areas are going to be more exposed than others to changes. Second thing is, are the animals that are going to be exposed sensitive to those changes? So for example, just looking at temperature, the sensitivity of different species to temperature varies. So some might have a kind of a wide tolerance to different temperature ranges, and others might have a pretty narrow tolerance. or range of tolerances. And that sensitivity can change throughout life history too. So typically juveniles have the kind of broadest range. And then the other thing is, what's their adaptive capacity to respond to those changes? So in this instance, we're looking at, can they move? Do they have the ability to adapt behaviorally by moving? And or what is their life history like? So is there a lot of variability where they can move to the ocean sooner, or have other life history traits that allow them to adapt? In this instance, we don't have a lot of data on genetic capacity to adapt, so we're using these other traits. So it's kind of that intersect here. If you are highly exposed, sensitive, and have low adaptive capacity, then you're highly vulnerable. If you're out in some of these other areas, you're less vulnerable. And so what we're trying to do here is assess the relative vulnerability of each of these populations using a range of attributes. So for exposure, these are the attributes we're looking at, a whole range here that reflect a lot of the stuff that you saw this morning. So the changes that you saw this morning are going into this analysis of vulnerability. And then for sensitivity and adaptive capacity, these are the attributes we're looking at in the assessment. The adaptive capacity attributes are highlighted in kind of an orange color there. And we're looking at each of these life stages, what's the current or historical kind of proximity to some climate threshold for each of those life stages. So for juveniles, for example, how close to some kind of climate threshold is that juvenile stage in that population of interest. And then down below here, starting with the cumulative, we're looking at some of these extrinsic factors and how they affect the sensitivity of those populations. So things like hatcheries, harvest, population viability, ocean acidification. How do they play a role in increasing sensitivity of those populations? In terms of the assessment process, this is an expert panel scoring assessment. And so we started off with a data and narrative, a lot of the data you've seen today. In addition to that, we also, primarily Kara and Matt and Courtney, have converted a lot of that data into a quantitative assessment of the impacts to the population of interest across their distribution. And so we included that with a narrative for each of those attributes. And then we had an expert panel discussion around each of those attributes, trying to understand what those folks were seeing on the ground relative to what the data is showing. And again, a lot of these models are good at showing big picture, but they're not good at showing kind of fine scale information. And so that's where having those experts really helps, having those years on the ground, understand where those local differences might be and where there might be some local adaptations. And the purpose of that expert panel discussion is to make sure that everyone has a shared understanding of what folks are seeing out there in the landscape. Following that discussion, there was a first round of scoring where each of the panelists was asked to score each of those attributes on a scale of low to very high. So it could be low exposure to very high exposure, or low sensitivity to very high sensitivity. Then we had a second discussion to kind of compare the scoring from different folks and have a discussion about why scoring might differ, what folks were seeing and how they were interpreting things. And then we're in the process of having this second assessment where folks have an opportunity to modify their scores if they desire. Tom, I think, mentioned earlier that this has been a little delayed because of the fires. We had a couple of panelists who had to evacuate, and other folks who have had their workloads increased significantly as a result of the fire. So we're hoping to get this wrapped up in the next few weeks here. So that's the second kind of piece that we're doing to understand how some of those changes might impact the plant species. Just going to talk a bit about how that gets rolled up and then how we use that information in the plan, and specifically how it relates to the discussion that we're going to have following this about the management strategies. So in the, Chris showed a table earlier for current status. We're going to have a similar kind of table that looks at how climate change might affect that current status. And this is kind of what it'll look like. So we're going to have a climate change impact index for each of water quality, water quantity, and marine. And those are the columns that are kind of highlighted in the brownish colors. A score of 1 means there's little impact, and a score of 4 means that there's going to be a lot of impact. So for each of those populations, we've calculated an index score, which kind of reflects the amount that they're going to be exposed, plus the presence of those life histories in those areas. And then, and that's just kind of a visual, so folks can understand what impact is likely to occur. And then the results of those two analyses that we just talked about, the species distribution models and the vulnerability assessment, will be populated in those columns and then rolled up together into a kind of a final risk evaluation. And so then that's all information that we can use. I just want to highlight how we intend to use it. The first way is in guiding expectations, and there's kind of a few ways that it does that. One is in understanding how some of the limiting factors that have been identified are going to change. I think Dan is going to go through some of the limiting factors up here in this region, and we can think back to some of the changes we're expecting in those limiting factors and how they might be, how the species might be impacted. And then whether any new limiting factors might come to light over the next coming decades. The second place is in expectation for desired status. So I think Chris mentioned earlier that one of the things that's upcoming is to settle on a desired status. So moving from current to desired in the future. And I think this information is useful in informing kind of those climate headwinds. So in some places where there's going to be a lot of change and it might impact populations, just maintaining current status might be, is going to require significant uplift, particularly around habitat. And so it informs those discussions of desired status and then difficulty in achieving that desired status. The next place that we use it is in guiding actions. So the management strategies. We're here today to focus on habitat. And so I think you can think back to some of those changes, particularly water quality and quantity, and then passage. So giving these animals the opportunity to move around and behaviorally adapt, and then ensuring that water quality and quantity is within their optimal ranges. And a lot of the strategies you're going to see here focus around these. So it's, again, similar strategies to what we've seen in the past, but it's focused in a different way because of this climate information. The other species I just highlight because a lot of the changes that we can make in a habitat can disadvantage these other species, which might be non-native predators, competitors, disease, etc. So changes in habitat can also be, or habitat restoration protection can also be beneficial in managing the other species interactions. It also is going to guide our actions around research and monitoring. So Kara mentioned some of the work she's doing on setting up temperature monitoring in this region. We're also looking at that statewide on the understanding that we need to have a really good handle on what changes are occurring with temperature and flow, because those are two of the things that are going to be really affected by climate and ocean change. So there's a lot of effort ongoing at the moment to realign some of our statewide monitoring, and particularly in this region, to capture those metrics of importance so that we can adapt our management as we go forward. And I wanted to go back just briefly to this slide, which is about the climate change policy itself and the implementation of that policy. Step 3 was where we incorporate key principles into this plan. But when we go forward and implement these habitat strategies that we're going to talk about here soon, there's some other pieces in the policy that are relevant. And one is this coordination of a long-term statewide response. And so you're going to see a lot of similar strategies, but the way we go about implementing those strategies is going to differ in light of this climate change information. And that long-term statewide response, which I'll talk a little bit more about here, is going to be key in really moving things forward. I talked a little bit about the key principles in development science, and that the policy directs us to monitor and incorporate some of those changes into our science. And I just gave some examples of that with temperature. And then 4 is applying those key principles into our consulting, regulatory, advisory roles. Again, that goes back into that long-term statewide response. And then the communication strategy is just sharing this information, making it available, and making folks aware of what we can do to mitigate some of these changes. So through the policy, climate policy, there's going to be a lot of changes in the way we implement some of the habitat management strategies that you're going to see. And just specifically, I wanted to hit on this because I think a lot of the strategies you're going to talk about are familiar, but again, it's the implementation that differs. And for habitat specifically, we use this climate change information to look at a large scale where we should focus this work. So if you think back to some of those maps showing changes in, say, the Middle Rogue Applegate versus some of the coastal basins, that kind of information can help you see where do we need to focus most of the work at that large scale. Then within that large scale, once you've decided where you're going to focus that work, this information can also help us decide what the targets are. So for example, if we're projecting a 2.6 degree increase in stream warming, we can look at what strategies we can implement to mitigate that, whether it's flow restoration, riparian planting, or some combination of them, and or upland management. So we're currently working with partners and internally to develop a range of tools that can help us do some of these management scenarios to understand what changes, what management habitat changes need to occur to meet some of these targets. And then I did mention that we're going to be increasing our monitoring presence for some of these climate change metrics that we can both assess progress towards targets and then assess how well the projections are actually tracking reality. And then the final piece, which is really important, is that lead and statewide coordination. It's going to be really critical that all agencies and groups are aligned in the same goals. So just to briefly touch on that, the way we view this is that we have these kind of coordinated inventories and vulnerability assessments across the different sectors. And so the one we're doing right now represents the needs of fish in this region. We want to kind of overlay that with other vulnerability assessments and then try and get a handle on clear priorities within and across these geographical areas so that we can, as a state enterprise and as partners, we can implement priorities in alignment across these areas and implement and align both the science, planning, regulation, on the groundwork and funding to get real uplift in these areas. So that piece is going to be really key. And with that, I think we're at the end.
So any questions for Sean?
Rich?
So can you hear me?
Yes.
Yes, we can, Rich.
Okay, so the climate change policy that was adopted says this is about native fish. Hatchery fish are native. It looks like you did not do a vulnerability or risk assessment for the hatchery populations in the Rogue River, which are substantial. And this is an error of omission is what I see. We need to know how climate change may affect our hatchery fish populations for obvious reasons, because they drive the fishery. So I'm just wondering why you aren't assessing vulnerability to hatchery populations in the Rogue.
Can you just clarify, you're talking about assessing the vulnerability of, or including hatchery fish in the assessment of wild fish vulnerability, or specifically assessing the vulnerability of hatchery fish to climate change?
Well, I mean, they're related, but the issue I'm raising is the vulnerability of the hatchery population. So we've got a major summer steelhead hatchery population. We've got a major winter steelhead population, and then we've got a minor coho hatchery population. So how is climate change going to affect their ability to reproduce or come back or whatever? You know, how are they vulnerable, and what is the risk to those populations? They're native fish.
Yeah. So just to the first point, the impact of hatchery fish on the as a factor for sensitivity for wild fish was considered in that wild fish vulnerability assessment. I think I think it's a good point that we could look at the vulnerability of those hatchery populations. Likely, what we typically see is that they perform less well in oceans, in poor ocean conditions than the wild fish. And given those ocean conditions that we're projecting, they would have higher vulnerability than some of the wild fish populations, but then at the same time, they're less exposed to some of the freshwater changes. So I think it's a good point. We could look at that. Tom, did you want to say anything about that?
Yeah, I agree. We should understand how climate change is going to be affecting our hatchery programs. The reason it's not upfront and explicit in what we've done already is because our native fish conservation policy really drives home the message and the policy that naturally producing native fish are the foundation for all conservation and utilization. So that's really where we focused the effort so far. But you do make a good point, Rich.
Can I make another one?
Absolutely.
Well, I don't know where this is going to fit in, but these models to predict average stream temperatures increases and decreases aren't taking into consideration the biology of the fish. So I've done a lot of snorkeling, and the fish down here are really good at finding cold water refugia. They're masters at that. And those cold water refugia only make up a very small portion of the stream, but they're providing habitat for a disproportionate number of fish. And so there has to be a fine scale effort to find where these refugia are. I mean, I can take you out to some where they're at least 5 degrees lower than the main stem, and there's hundreds or maybe thousands of coho rearing in these off-channel cold water habitats. And there's upwelling in the streams as well. There's trib junctions, all kinds of places where these are, but they're micro habitats. So an approach that just wants to monitor and change average temperature is going to miss the boat on that.
Yeah, for sure. That's a well-recognized limitation of these models. And I think part of what Kara is doing, part of what we're doing in a kind of parallel effort is to understand where those microhabitats are and bump them up in terms of prioritizing their protection. It's just really difficult to figure out where those are on the landscape. And so we do have a parallel effort going on to try and identify where those are statewide. Kara, did you want to talk a bit more about that? Or is she gone?
No, I'm here. I'm here. No, yes. So as Sean mentioned, it is really challenging, and a lot of the best information comes from people like you that are out on the ground. And so that's one of the things that we've done is we've really censused our own agency biologists, that are really familiar with their areas. And then, one of the better tools, it's not the best, is using what's called forward infrared. It's called FLIR data. And so it's a flight that flies over the stream and then measures basically at that surface temperature. Now it's not getting at those deeper upwelling deep pools where you've got cold water, but it's one of the best tools we have to identify that. And it has been flown in a number of places in the Rogue. Our goal or our proposal would be to get it flown more frequently and to cover the basin. So that is definitely something that we've been talking about and are interested in improving our information on that.
And I believe we will see some actions when we get to the temperature section and the habitat strategies and actions around that. And as Sean has said, adaptive management is part of this, and totally agree with you, Rich. Those places are going to be important. We need to know where they are and adapt as we understand where they are in terms of what our actions are with respect to protection and restoration.
Hey, Tom, I see that Kyle has unmuted his microphone. Kyle, just want to make a comment or share a question? Kyle, do you hear me?
Yeah, sorry, I had my phone on mute as well. appreciate Rich's line of discussion. Also wondering about impacts of wild harvest in the face of climate change, and particularly with an eye towards genetic diversity, and how important those wild stocks will be moving forward under increased stress from a changing climate.
Yeah, so Kyle, I kind of glossed over that piece about how we use that climate change information and those kind of measurement strategy categories of harvest. But there's a couple of things there. Three actually. One is that in general, we scale harvest to the health of the population. Obviously we can't bank these fish going forward. So you have to manage it adaptively depending on what's coming back to make sure that you have enough fish going forward to sustain the population. So in general, you'll see like a scaling kind of framework for harvest that in poor times adjusts harvest downward and good times adjust it upwards. We're going to continue to see those cycles with PDO and ENSO where we have good and bad years, and that'll just kind of oscillate through time with a general trajectory in one way. And then second is responding to environmental conditions at the time. So when fish come back, we can either have high flows, low flows, high temperatures, low temperatures, and that's depending on what those conditions are, we adapt the fishery at that time. And I think Steve yesterday had some good examples where we've recently shut down some fisheries because of low flows or high temperatures, and we'll continue to do that to make sure that we're not adversely impacting these fish. The second thing is perhaps identifying some of these refugia where they're holding, particularly for summer fish, and adjusting harvest in those areas. So that's kind of the adaptive in-season management. And we're looking also at developing a framework around that. And then third, it's those life history characteristics that you talked about. And that's where you don't want to adversely impact one part of the population that's going to be particularly important going forward. I think you see some examples of that in our spring Chinook plan, where we're looking to reduce harvest on those early run fish to maintain that really important life history. And so there's a whole range of ways that we're thinking about incorporating this climate change information into harvest management.
And those are all things we've talked about with the stakeholder group. So we didn't do the greatest job explicitly linking those things to climate change strategies, as Sean just outlined in that respect.
Yeah, appreciate that. Appreciate your explanation there, Sean. I agree, Tom, that we didn't go as in depth into the impact of climate change on some of the effects of wild harvest, and I'm reluctant to talk more about it since I recognize this is a habitat work group. But maybe we could talk offline.
Absolutely, happy to do so.
Thanks,
Tim.
Hey, thanks, Tom. I just want to follow up with Sean. I think Sean's explanation there of the effects of climate change really just emphasizes the need to manage at the population scale. I think, again, one of the, if it can be called a bright point of the presentation, is that the effects of climate change are not going to be uniform across the landscape. So I think, again, just to emphasize that we need a population scale management plans, not SMU scale, because again, populations will be responding differently in different places. So if we manage at a larger scale, we're going to be losing some of that, some of the nuance. I just want to throw that in.
Thanks, Tim. Yeah, we assess things at population and then roll it up to SMU scales, but these actions are happening with populations in mind, and priorities are going to be even at a smaller scale than that, is our anticipation. So we agree with your statement. Any other questions? Okay, with that, it is time for a break. We're a few minutes behind schedule, so why don't we take a 10-minute break and start back up at 11 o'clock. So we will talk to you then.
Steve, you saw my private message. If you still like to work on merging the audio with your computer, I'm happy to help right now. Let me know.
That's fine. Can you hear me?
Yes.
Okay. It's working all right through my phone now that I got that kind of figured out. But
Okay.
That's yeah, I think it'd probably work best with the phone. That's why I've done all the other meetings, So.
Okay, good. So if that's working for you, then we're good.
Yeah. It was getting the mic turned on the or whatever on the screen, but I think that's what's going on. So.
I'm actually just curious from the users end, so I can give better orientation next time. Is right now, are you using your phone for audio and then separately your computer or other device for visual? Okay. And to unmute yourself,
and I didn't.
You had to enter the
and I
star
didn't.
6. I'm sorry.
Yeah, I didn't figure out how to use the video part of it until last meeting that we had, and so I don't think it was explained very well, and I don't know if anybody else had that, but it took 5 or 6 meetings before I got on video. So. Got it.
And right now, to get your mic turned on, did you have to enter the star 6 key on your keypad?
No,
Okay,
I just I had called in, and it followed the instructions as far as using the phone for the audio.
Good. All right. Good to hear. All right. Well, thank you.
Thank you.
Kyle and Steve, I'm going to go ahead and mute you both, if you don't mind.
Okay, why don't we get started back up? So we are going to be moving into the discussion on habitat management strategies and actions. Like Sean said, these are things that we've been doing. The climate change assessment and adaptive management are going to help focus these better. But these are the general strategies and actions that we see as being needed to address the limiting factors. Climate change is going to be exacerbating. So with that, I'm going to hand it over to Dan Van Dyke, our district fish biologist, who's going to give us an overview of the stratum to start off. So Dan?
Good morning, everybody. My name's Dan Van Dyke. I'm the district fish biologist for the Rogue District, managing with my staff. Basically fishing from the headwaters near Crater Lake all the way down to Agnes. And in the lower river, that management lead switches to the Gold Beach office, the South Coast District. So just a quick thought before we get going. I just want to point out that in the information I present, the Rogue is a highly productive river for salmon and steelhead, even with all kinds of impacts that we'll touch on here today. We're still shaking off the effects of bad management practices from historical development over the last 100, 150 years. So we'll go into that here in a bit more detail. So I think, let's see if I can. Okay, is everybody seeing that?
Yep, looks great.
All right, so this is just a quick, so I'm going to present an overview, basically some context about the Rogue leading into a discussion of management strategies and actions. This is just a quick pictorial life history of steelhead. So you can have all the fry you want, as shown in that upper left photo, but unless that fish can live for 2 to 3 years in fresh water, like that gorgeous fish in the middle photo, that's something Pete Samron collected, that fish in Cane Creek near Gold Hill. Unless the fish reach that stage, we're not going to have more fish returning as adults like we all want. This is where habitat comes in. This is where stewardship comes in. So I can't talk about the Rogue without talking about this slide and dam removal. So in quick succession, 2008 through 2010, we saw the removal or notching of 4 large dams in this watershed. So 3 older dams on the main stem, Gold Hill, Savage Rapids, and Gold Ray. And it's easy to forget and lose track that Elk Creek Dam was notched as well by the Corps. Collectively, this is something my predecessors could only dream about. And I could talk a lot more about this slide alone, probably take most of the day talking about this. But at the very least, we have a huge head start on adapting to climate change and increasing resilience thanks to this work that has already taken place. I'd like to actually have a retroactive management action, including this in our plan. I also want to add, Russell Sadler years ago eloquently said that ODFW is the keeper of the data. Well, we're also the keeper of the clock. So the first year that was basically main stem dam free for native migratory fish was 2011. So we didn't even start to get adult returns until about 2014, 2015. In my experience, it takes at least 20 years, 4 or 5 generations, to really tease out fish response from habitat restoration actions. So I just want to add, when you think about what these first returning years have faced when it comes to a multi-year drought, a big El Nino, very similar to conditions in the early 90s, and then on top of that, the oddball warm ocean conditions in and around the El Nino, we haven't seen yet what the fish response is going to be to these dams in true effect. I'm actually very excited about what's going to happen in the next 10 to 15 years. So I like to talk, and this makes everybody in Fish Division roll their eyes. I like to talk about how the Rogue is unique. So we are quite a bit different than other coastal watersheds in Oregon. One way we're unique, we have a human population that absolutely dwarfs the other coastal populations in Oregon. So the next most populous is the Umpqua watershed. When I checked Blue Book, Douglas County has about 110,000 people. We've got close to 300,000 just in Jackson and Josephine alone, not including a portion of Curry County in our watershed. So a lot of people means collectively a lot of impacts to fish producing habitat. We're also different from Oregon coastal watersheds just in the related fish species. So this slide shows on the left the Klamath Mountains Province steelhead DPS. So our steelhead are collectively associated not with other steelhead populations to the north of us in the Oregon coast area. Our steelhead are most closely related to Northern California steelhead. Similar way, on the right, you see the SONC ESU map. And again, our fish are closer aligned to the fish in Northern California than the Oregon coast. If you want to compare our fish to other populations, compare us to California, don't compare us to the Oregon coast. We're naturally a warmer and drier summer climate than the rest of the Oregon coast. And you can see this isn't the best slide. This just came from a NOAA document in the, 95. And if you can notice, the dots on the rogue are intended to represent annual max monthly stream temperature. Well, every dot there is listing temperatures between 64 and 71 degrees Fahrenheit. I only point this out just to say we are, again, naturally warmer than a lot of other salmon and steelhead producing areas. So our starting point for climate change is naturally higher than you might normally expect. So we're also unique in steelhead life history. I won't spend a lot of time on this. Chris covered this already about the half-pounder run. Summer steelhead also have evolved to utilize intermittent streams that dry up naturally as spawning habitat. Fish spawn with winter storms. The eggs develop throughout the winter, and the fry actually start to migrate downstream soon after hatching and actually rear in larger tributaries or the main stem rogue through the summer before heading back up. And we'll talk about that in just a sec. So the most important spawning streams would surprise somebody who's not in this area. They're actually small, often intermittent streams between Grants Pass and the Gold Ray area, including Antelope Creek. That's the historic breadbasket for our summer steelhead population. So our juvenile fish move around a lot. And one good example of this was one of the studies that Fred Everest did in the 70s, contributing to his excellent report on the ecology of summer steelhead here in the Rogue. So he marked steelhead fry leaving Cane Creek, and you can see that the arrow to the right shows where Cane Creek is. So he marked steelhead fry leaving Cane Creek as it was drying up. And then he found those marked fry over about 20 miles of the Rogue River that summer. So those fish were rearing from basically Fruitdale Creek near Grants Pass here on the left, all the way up to, some of them actually swam upstream to Sam's Creek below the Gold Ray Dam site. That's where they spent their first summer. In the winter, boom, they went up into several different streams, not necessarily Cane Creek. These fish entered several streams throughout that very same reach. Again, these marked fry that he collected leaving Cane Creek originally. So our fish move around a lot. That's been well documented. I have little doubt that our fish evolved for that with our harsher, naturally harsh climate for salmonids here in the Rogue watershed. Now, our fish move around a lot if we let them. The problem is all the barriers we put in their way. So this is another little bit of data from the 1970s. On the left, that photo is culvert on a frontage road at I-5 on basically at the mouth of Cane Creek. So all the fish produced in Cane Creek have to get up through here. And that's even with this kind of rudimentary ladder structure that was built at some point. But in the 70s, we went out in the wintertime and looked at the density of juvenile steelhead above and below these barriers listed on the table on the right. Cane Creek, Galls Creek, Jones Creek, Fruitdale Creek. The densities of juvenile steelhead in winter, and remember that our juvenile fish are then, with the fall rains, are moving back up into these tribs, much higher below the barriers than above. I would love to talk more about Jones Creek. We don't have time, but look at the density below the railroad crossing on Jones Creek, over 400 juvenile steelhead per 1,000 feet in the sample. And then I think it's just 3 upstream. I should tell you that none of these sites were improved for fish passage until very recently. And we may talk more about that here in a bit. Dan Delaney and the Stream Restoration Alliance did a great job improving passage on Jones Creek. So passage has been known to be a big deal on the Rogue, and a much bigger deal on the Rogue than for native migratory fish compared to other coastal watersheds. Cole Rivers noted that back in his work in the 40s and 50s. So Cole reported that several hundred dams were present within the range of migratory fish leading up to 1941. Now, a lot of them were small and could be passed by fish when conditions were good for passage. But even Cole noted at that time that during winters with low flow, dams less than 30 inches in height would reduce the distribution of steelhead on the spawning grounds. Pretty interesting stuff when you look at the number of sites we have that can block fish. But don't forget, still, even with these challenges, highly productive river. I want to add really quickly something else about dams, the core dams. So this is another way we're unique. And I have little doubt that the only reason we have what we have with the core dams is because citizens, a lot of you on the phone, your ancestors, if you will, fought hard for the Rogue River and its fish when these dams were being proposed. What's unique about the core dams is that they actually have fishery, it's called fishery enhancement, as a primary purpose for these dams here on the Rogue, for Lost Creek and William Jess Dam, Lost Creek Reservoir, and Applegate Dam. We're not aware of any other place in the Northwest, maybe in the country, where fish needs are listed as a primary purpose. And that's even more important than hydropower, which is produced at Jess Dam. Pretty unique, and a lot of that is accomplished through an allocation of stored water that is dedicated solely to fish. A lot of it is related to how the dam is operated outside of flood control. The Corps must operate in a fish-friendly manner when they're not doing actions to minimize flood damage. And I have to say, thanks to the leadership of Tom Satterthwaite for ODFW and Jim Buck, now retired project leader at the Corps, we have an excellent working relationship when it comes to dam reservoir operation. And the Corps truly has been very responsive to fish needs, at least since the adoption of the Spring Chinook plan. So there's a lot of work that's done related to that, and a lot of good work that's done to help fish out. I did want to add, Steve brought up blue-green algae blooms. I'll just use this point to mention that as soon as the dam was finished and filled, there was a blue-green algae bloom. It's actually in one of the first reports, or one of the reports that came out of the Rogue Basin Project studies. So when you dam up a lot of water in a hot climate, you're going to have blue-green algae blooms. And the Corps has looked at potential sources of like point sources that could be contributing. But as I understand it, if you have a certain geology that results in a certain nitrogen phosphorus ratio, you're going to have blooms not of algae that are good to feed the whole food web, but you will tend to have the bad algae, the blue-greens, coming about. So that just wanted to mention that really quickly. Steve Byerman has also brought up concerns about the mitigation package associated with the core dams, whether there was, and I apologize for paraphrasing for you, Steve, but he's brought up issues with whether the true impacts were accurately identified in that mitigation package associated with the core dam. So there is going to be more discussion. ODFW does plan to talk more with Steve and others in the stakeholder group about that issue. One other highlight I just want to mention, then we'll move on. This is actually one of the projects I'm most proud of, although I just played a small role, the Fielder Dam Removal Project. This we have to thank Bob Hunter and Water Watch, as well as I think Brian Barr is on the phone, played a key role. Fielder Dam was located fairly near the mouth of Evans Creek, and it was not a good place for fish if you want to move upstream. It was an abandoned dam on top of it, no longer used for irrigation, had a very rudimentary ladder. And what I want to say to this is in previous droughts, if you look at ODFW monthly reports, during past droughts, ODFW actually came out and netted steelhead over this dam. They weren't able to get it over the rudimentary fish ladder. They kegged up down below, and we went in and did our best to try and move them up and over. And there were some pretty good numbers that were netted. This dam is gone, along with Weimer Dam, I think River Mile 8. It's been a while, I'm getting rusty. And I wanted to add that in the drought of 2020, so we've been in a drought year this whole year, we had winter steelhead adults up into the West Fork at least 20 miles upstream, volitionally passing, wherein they probably wouldn't have been able to pass this site before the dam was removed. Just an encouraging anecdote as we move forward. Again, another example of a project that is increasing resilience to climate change just through passage restoration. Chris, I think I'll, with that, turn it back to you.
Okay, thanks, Dan. Go ahead and stop sharing, and then I'll. Oh, great.
Oh, did I?
Oh, that's great.
Okay.
All right. With that overview, I'm just going to give a brief overview of my own of the overarching habitat management strategies that we've proposed in the packet. And I'm just going to read through these with adding a little bit of context, some of it based on the discussion we had yesterday with the other group. And in thinking about putting these together, one of the big overarching considerations is in this opening paragraph on page 32 of your packet. Let me make sure that that matches the, yeah, on 32, page 32 of the packet is the major difference, or the important difference, between the coastal watersheds, which includes the lower Rogue in this case, and the interior Rogue Basin, due to some important intrinsic factors that are you have to do with geology and climate, and then also the extent of development in the interior Rogue that Dan talked about, in the human population, and just various kinds of development and impacts on the landscape. So that's an important part of how we're thinking about the approach we need to take to address limiting factors, and also thinking about the bigger climate picture as well. So I'm just going to read through these, and then we can take some questions about them. The first one is to identify watersheds that will be key to supporting plant populations in the future, and focus habitat protection and restoration activities towards these watersheds. So this really connects with what Sean was talking about earlier, that we need to prioritize and really put our money and our effort in places that are going to give us the best shot in the future to maintain these populations. And there's an important footnote that's noted on that number one, that if you go down to the bottom of page 32, that talks about exactly what we mean in this document by protection activities and restoration activities, with protection being activities that reduce or eliminate potential impacts to maintain existing fish habitat, either on a voluntary or regulatory basis. And then restoration activities are those that improve existing fish habitat, primarily on a voluntary basis. So just please keep that in mind as we go through this. Number 2 is to primarily focus habitat restoration activities in interior rogue watersheds. That would be the Illinois Middle Rogue, Applegate, and Upper Rogue, and prioritize actions that address primary and secondary limiting factors. In our discussions yesterday with the other group, we realized we may need to reword this a little bit, but I think the overarching concept here is that the scope and the kinds of restoration activities that are needed in the rogue is where the primary need is. So we certainly have restoration opportunities and needs in the south, in the coastal basins, but the rogue is where that biggest lift is going to be needed. And you'll see that in our actions that we've identified and how many of them are specifically focused on the interior rogue. Number 3 is to coordinate with and advise other agencies, local governments, and other regulatory entities consistent with ODF&W's mission, policies, and laws to ensure that habitat protection processes and outcomes are providing a benefit to native fish, and again, with a focus on priority areas. This is part of our, part of this point is that ODF&W doesn't have necessarily regulatory authority in a lot of these areas. And so for us, coordination is a key strategy for making some of these actions happen on the ground. So, and where we do have regulatory authority, certainly we're gonna, or we have, especially around fish passage, that's a primary responsibility of ours. But in some of these other areas, we don't have that regulatory authority. And so coordination is the key strategy. Number 4 is to work with restoration partners to complete projects addressing primary and secondary limiting factors identified in the plan and actions identified in Coho strategic action plans, including the one that's currently underdeveloped for the Upper Rogue. Also to update watershed assessments as necessary. And certainly in our conversations yesterday, it came to our, it was brought to our attention that we may need to broaden this and change the language here to include more planning processes. We really think that those Coho business plan, Coho strategic action plans are a key thing to consider when we're thinking about actions on the ground. But there's other plans and processes that we could also include, and we could talk about that today. Number 5 is to lead the implementation of actions to adapt to climate change, which I think is, again, connects back to Sean's talk really closely. Encourage citizen involvement to help implement habitat protection and restoration activities. We feel like this is a really important in an area where there's a lot of opportunity. And finally, promote beavers and beaver-related pond habitat to increase water quantity and stream complexity, primarily through repairing restoration and helping landowners learn to live with beaver impacts. And so we've got some specific details about how we're going to implement that under the action section, but this is an important strategy that both to increase habitat quantity and habitat quality for the planned species. Beavers can be difficult to live with, and so yeah, digging into this one, and I think we'll get into some of the details down in the action sections, as I mentioned, that Dan can talk about a little bit more. But,
hey, Chris.
Yeah.
Can I just add 2 quick things?
Absolutely.
So especially in our draft plan, I see us weaving strategy 5, climate change, and strategy 6, citizen involvement, throughout our list of actions that are all intended to address primary and secondary limiting factors. So I think it's already been stated, but climate change basically makes long-standing manageable limiting factors even more significant for these species in the coming decades, basically synergistic effects to the negative. Conversely, citizen involvement can help fish, and I think it's especially important for habitat protection. And that relates to just needing citizens to communicate with agencies that about the importance of enforcing and following through on rules that protect habitat. It's tedious, it's not glamorous, but it's very important. I just wanted to sneak that in.
Okay, thanks, Dan. Yeah, and so The reason why we have these kind of as just a whole separate group is because they cut across so many of the actions and the limiting factors that are listed down below. And so they kind of, yeah, they're cross-cutting strategies that are going to apply to a lot of the different actions that you see down below.
So before we move into the details of the actions around habitat access, any questions for Dan or Chris on the overview or overarching strategies? Okay, so with that, why don't we move into talking about the habitat access module. And let's see, Dan, you're gonna kick this off? Okay. Dan, you're still on mute. Dan, can you hear me? You're on mute.
Yeah, I'll unmute you from my end. There.
What did I tell you about operator error, Tom?
You were doing so well.
Dang. Okay, we already talked about passage and the importance of the issue of restoring passage, how important that is for interior rogue populations. So I just want to describe in this slide where exactly we rated the issue of access and passage as far as limiting factors in this watershed. And then I have a few slides to share before we talk about the actions to address these limiting factors. So for general passage, ODFW considers that to be a primary limiting factor in the mid-rogue Applegate and the upper rogue areas. Just a possible limiting factor in the Illinois. The second category, water diversion, basically affecting upstream and downstream fish movement. A lot of this is related to fish screening. We consider that to be a primary limiting factor, again, in the mid-rogue, Applegate, and upper rogue, and just a possible limiting factor in the Illinois. The final category in this section is peripheral connectivity, and basically that's floodplain connectivity, access to natural off-channel habitat and side channels and things like that. ODFW lists that as a secondary limiting factor in the mid-rogue, Applegate, and upper rogue.
And Dan, maybe I could just quickly jump in and orient those, especially those on the phone, to the packet. The slides and things Dan are talking about are summarizing what's on page, or actually probably going into more detail than what's on page 30, which is a table which goes through limiting factors and whether or not they're a primary and secondary concern or uncertainty. Critical uncertainty. And today we're dealing with those, the whole bottom portion of that table in green, which are the habitat-based limiting factors, starting with habitat access. So we're on page 30, and then the actions that start on page 33 of the packet are gonna link back to those limiting factors. Sorry for the interruption, Dan.
Not at all, thanks. Just a couple of quick slides before we go into the actions. So we have a priority list of prioritized barriers. This is one of them, Harbolt Dam on Slate Creek. Jim McCarthy at Water Watch is doing great work. This one is slated to come out soon, no pun intended. There is an added benefit. On the lower right, there was a dam on a nice little tributary of Slate Creek, actually 2 dams that are also going to be removed, which is a wonderful package deal. Another priority barrier is Seats Dam on Rough and Ready Creek in the Illinois. Here's Roland Smith, Site 2 on Yale Creek. We don't have too many barriers on the Rogue that are absolute barriers. No fish can pass, like the Elwha or what was it? Maybe the white salmon. Most of our barriers are partial barriers to fish passage. On a lot of them, when conditions are good for passage, fish can pass. When conditions are bad for passage, nothing's moving. This site is one of our sites where we actually obviously have a complete barrier. I don't know if you can tell. Can you see my cursor?
Yes.
Probably not.
Yeah, we can.
There's an adult steelhead jumping at Granite Street Dam right there. This is on Ashland Creek in the city of Ashland, just upstream in Lithia Park. Of course, through our abundance here in the Rogue, we have a whole lot of other sites that will never make it onto our priority list. Pete Samarin, one of my assistants, has eloquently referred to them as stupid dams. Upper left is just a monitoring weir at Caldera Brewing in Ashland that has a plate here that is not good for passage. We've seen steelhead struggling here. Upper right is a remnant of the old Kirby Ditch in Cave Junction, affecting George Creek. Can you see juveniles trying to pass that in winter? Lower right is somebody really went to town on Sand Creek and Grants Pass. And then lower left is a site on Elk Creek, just upstream of 199 in the Cave Junction area. A lot of sites that, again, may never get on our priority list. ODOT certainly has sites that we work with them on to restore passage. Here's a Highway 99 culvert on Coleman Creek. Screening is definitely an issue. So on the left is the irrigation ditch when it was unscreened on Lost Creek, a tributary of Little Butte. This has been a high priority for us to screen for, I wouldn't be surprised, a couple of decades now. It just was completed this last fall. So that's the new screen in operation on the right. Very exciting. Now juvenile coho, juvenile steelhead won't be heading down into ag fields thanks to the help of the irrigator and BLM and our screen shop. Push-up dams are definitely an issue on the Rogue, but less of an issue than they were the last time we had a multi-year drought and big El Nino, et cetera. Since the early 90s, there's been a little bit better stewardship with push-up dams today. So a lot of them are partial channel spanning. They push water towards the irrigator diversion, but still allow fish passage. Still a potential concern, especially if irrigators respond to lower and lower stream flow a couple of decades down the road. Or less well-known site where passage is an issue is trash racks in urban areas. There are several sites around Medford where the trash racks weren't built to our specifications, and you can see this one at Lone Pine Creek at the bowling alley. When it gets debris, it's a dam. And the last example I wanted to show, this is actually an update to our stakeholders. I think Pete showed this back at our first meeting. I don't know what this is to this day, but it's my understanding, and it was either Maple Gulch on Evans Creek or Maple Creek. Lauren Brown, I think, is on the phone, but it's my understanding that thanks to Lauren Brown at DSL, this is no longer in existence, which is a huge win for fish on this small creek. So thank you, Lauren. So with that, I'll go into the actions, but Chris, can you get the actions up on the screen?
Chris, you there?
I'm working on it. Just a second.
Okay.
Sorry. All right. Can everyone see that?
Yes. Thank you.
Got it. So Dan, I will just plan to move this around as needed and just direct me if you want me to move it in any direction.
So you can't just ship that to me, or I'm fine with that. Okay, well, let's go through the actions that we're proposing as key management needs for addressing primary and secondary limiting factors. So we have 5 key management actions addressing passage. 1.1 is pretty obvious: remove priority barriers for adult and juvenile fish. So I think we've touched on this before. This is a critical need in response to climate change. Fish need to be able to move where they want to move, when they need to move, to be able to survive in fresh water. So the Rogue District has over 80 sites on the statewide priority list. I believe we dwarf most of the other districts because of our plenty. And there's just a whole lot of work to do, remaining to be done, working on those priority sites. So we also work with agencies like ODOT to improve passage at their culverts. So we actually meet with Jerry Vogt, Doug Sharp, and others at ODOT every couple of years, I believe, review sites that they've worked on, look at what's left to do, and then plan projects. I gotta recognize ODOT, Jerry Vogt, for the work that was done on Cane Creek. We already showed a photo of that culvert. ODOT did a fantastic job on Cane Creek, removing a culvert barrier and improving passage at that frontage road culvert. Just really good work, and I want to thank them for that. And that also was fairly recently done. So action 1.2, basically we will regularly update the list of priority barriers. Again, pretty obvious. So there are a lot of factors to consider that are considered during barrier prioritization. And one thing here in the Rogue is a lot of times we end up with finding new sites. Dan Delaney and the Stream Restoration Alliance working on Jones Creek. Suddenly on the East Fork, they find this dam that nobody knew about and wasn't doing anything. That is now gone. So again, we will continue to review and prioritize with our partners and use our ODFW methodology to prioritize barriers now and into the future. But I do want to mention that those sites that will never make the statewide priority list, they still affect fish. So we do want to still include those, perhaps for consideration for low-cost community-based projects or packaging with higher priority sites where feasible and where it makes sense. Yeah, those sites still affect fish. Another technique we think has use is action 1.3. So in urban areas, especially where there's a large pool of potential volunteers, we think there's value in working with interested community members to install and maintain temporary structures to improve passage. Obviously, that's got to be consistent with regulatory agencies, but we're talking here just temporary stuff, things like gravel bags, potentially little plywood steps, things like that. we think can provide and approve passage at some of these sites that, again, will never make our priority list. Action 1.4, barriers are such a big deal here in the Rogue that we propose to use habitat models to estimate fish loss, the amount of habitat that's affected by these barriers, the fish productions that's lost as a result, but as well report on improvements in habitat gains and extrapolate that to improvements in fish production over time. I think that's going to be a good bit of business. We've already got some estimates on Bear Creek, crude as they are, detailing the amount of habitat blocked by barriers and the amount of fish affected. Happy to share that with people who might be interested. Lastly, in this section, we propose to develop outreach material on and training on proper culvert construction. This is about preventing future barriers as well as prepping for climate change. And there was actually a previous effort led by the GEOS Institute, University of Oregon, to plan for climate change specific to the Rogue watershed. And certainly, I'm trying to think of the phrase they used, upgrading our road system and having properly sized culverts for potentially changes in how our precip comes down is critical. We would love to work with watershed councils, partners, and engineers to actually develop training for the people that install culverts, talking to the general public as well as potentially county road engineers, just to head off future barriers in the future. And that ends that segment. So next, we move on to key management actions addressing passage associated with diversions. And again, this is primarily about screening. Although there are areas in the Rogue where so much water is diverted that it actually affects downstream of a diversion, affects upstream and downstream movement. So we have that as well as an issue in which we'd love to work with irrigators to improve that situation. But action 2.1, we certainly need to continue to, at priority sites, install screens at unscreened diversions. I mentioned that Lost Creek site is a really exciting development, but I want to be clear, we still have unscreened diversions that kill wild steelhead to this day. Still work to be done there. Action 2.2 is kind of a subset of the issue of diversions. We have, of course, an irrigation season that runs typically April through October. That can affect different species depending on which end of the time period you're talking about. Obviously, April, that can affect winter steelhead as well as Pacific lamprey and migration. At the other extreme, on a couple of trips might affect spring Chinook, but definitely affects fall Chinook in October. We'd like to do and plan to do outreach on placement to reduce the risk and improve passage at those sites. So I just lost the actions on my screen. Did I do something?
I think it's on Chris's end. I think he was the one displaying it.
No, he's not in the participants list right now. I wonder if he just got kicked off.
He might have had some connectivity issues. Let me.
Yeah. Do you have a copy?
I have a copy. I'll pull it up.
Great. And I'm not sure. I stepped away for a minute. And I see Steve's question here. I'm not sure if that was addressed, Dan. About 1.5.
No, we missed that, or we haven't gotten to the questions yet.
Okay.
Dan was going to go over the habitat access. So let me.
We just have one more section.
Okay. Okay, can people see that?
Yes, thank you.
Yep.
So the last section listing actions related to access is peripheral connection. So we list the next 4 key management actions address lateral passage basically and access and connectivity in the floodplain. We still think it's critical that riparian protection, growing mature riparian vegetation, mature trees that die, become large wood, create structure in stream channels. Ultimately, that's critical to maintaining stream structure that by default improves access within floodplain habitats. That's job 1. And we'll talk about riparian habitat in multiple places here in our list of actions. So action 3.2, ODFW will continue to comment on removal fill permits and other permits, but certainly removal fill permits that can negatively affect stream structure, function, and floodplain connectivity. I mentioned Lauren Brown is our local rep. I think we have a really good working relationship with Lauren. We also want to do outreach on the importance of large woody debris in maintaining connectivity. I know this is something Brian Barr brought up specifically, and I think we'll be talking about some related actions here this afternoon. But outreach on that issue is something that we want to do, again, as part of our effort at helping ensure peripheral connectivity moving forward. Action 3.4 is working with restoration partners to reconnect side channels and increase connectivity at specific sites. Now, I don't think this is a prescription that really applies broadly throughout the watershed, but at specific sites, that is something ODFW supports. And one site stands out by far, and that's Elk Creek. Elk Creek on the Upper Rogue, because of the opportunity provided by the public ownership of that valley bottom. So basically, if folks don't know, the Corps notched Elk Creek Dam. The inundation zone that never happened is now available to see habitat restoration and produce more fish. It's an exciting development and one that I know Brian Barr in the Upper Rogue Coho Strategic Action Plan is outlining as we speak. I want to add one other thing on peripheral connection is that fixing barriers on small tribs also improves peripheral connectivity. And I think it's especially important in areas like urban watersheds like Bear Creek, where we don't have a whole lot of floodplain. I mean, that was lost decades ago. This was referred to as linear connectivity in the GEOS report on climate change for the Rogue back in mid 2000s. But we shouldn't forget that just ensuring that fish can get up into little tribs actually in effect can serve as a surrogate for floodplain connectivity, especially in urban areas. That's what I had for discussing our proposals for management actions. I guess, Tom, we open it up to questions, or Chris?
Yes, we do. So I am going to stop sharing because I cannot see the participant list while I'm sharing, at least in the way I've shared this. So
I'm happy to keep an eye on the raised hands if you'd like to keep that slide up. It's up to you.
Okay, well,
Yes.
I took it down for now. I'll pull it back up if we need it, but
Sure. I see Steve's hand up. Steve, go ahead and unmute yourself.
So Steve, we're not hearing you if you're speaking.
Okay, that I just unmuted from my end. That might work.
If you're referring to Steve Burns, thank you for trying to unmute
sorry.
me there.
The wrong name, Steve.
Gotcha.
Sorry.
My question I just typed into the chat box, and you guys can answer it at your leisure. Thanks.
So
Okay.
Steve Berlin, I just unmuted you from my end. I'm not sure if that's working on your phone. Again, on your phone keypad, enter *6 if you have any issue. Oh, there we go, I think. Yep, there we go.
Can you hear me now?
Yes.
Yep.
Okay. Dan, great presentation. You hit on a lot of the stuff that's near and dear to my heart on this list that you have here. There is something that's concerned me for some time, and I haven't been there for a while, but the area from Tuvell to the old Gold Ray Dam site is quite braided in that area, so the off-channel opportunities down there are pretty high, and I know but a lot of people don't, but there was an old area of Salmon Rock that got kind of, the river moved over when it found gravel ponds on Wilton White's property after somebody had cut down a bunch of large cottonwoods, 3 or 4 foot through, and anyhow, last time I was there, those trees hadn't regrown on that bank. It was pretty bare. The old Gold Ray Dam site had a lot of off-channel rearing for fry and smolt. Some nights when I went through there, it was like it was raining fish jumping. But there's potential for that to move upstream to the old Wilton White ponds that were dug out for building I-5. And I think that's a real area of concentration between Tubell and the old Gold Ray Dam site for restoration. I'm also concerned about on Elk Creek, the culverts that were put in place for the flooded lake, and that those are working properly, and those need to be reviewed. It would be great to have a spawning channel on Elk Creek as well. But those are some of the thoughts that I had. You did a great job, but I'd like to, kind of put those out there for consideration.
Thank you, Steve. Let's see, Steve Burns had a question about would 1.5, which was about passage outreach material, proper culvert construction. Would that be required when obtaining a permit from DSL and the Army Corps of Engineers, fill removal permits? We certainly have no authority to require that of those agencies, but it's certainly something we can talk to them about providing as informational to them. Dan, I don't know if you have further thoughts on that.
Certainly when we get asked by citizens about permits needed for culverts, we 100% of the time say, talk with DSL just to make sure, because chances are extremely high that the culvert volume will trigger a need for permitting by DSL and potentially the Corps as well. I almost guaranteed the culverts replacement will require a removal fill permit. Unless I'm reading the question incorrectly, the training, there's certainly no requirement in removal fill permitting for that training to happen. But a removal fill permit is required in almost all cases for culvert installation, if that helps.
Steve Burns, did that get at your question?
Yeah, I think it did a little bit. I'm also interested in the Department of State Lands and the Corps and what the requirements are when they have a new or replacement culvert proposal, do they consult with ODF&W for appropriate aquatic organism passage?
Hey, this is Lauren, if folks can hear me from DSL.
Hi, Lauren, we can hear you.
Hi. Yeah, I was just gonna say, so when we receive a removal fill permit application, that goes out for public review, and ODFW has the opportunity to comment there. And so we pass those comments on to the applicant, and that, you know, we always are working with ODFW to make sure there is fish passage there. And so I really prefer to work with people before they go through the permitting process, because we have an easier permitting process, our general authorization. And so before you apply for that, the person actually talks with ODFW and gets sign off before that. And those projects are installation or replacement of fish screens, barrier removals, and removing or replacing existing culverts. So they're all kind of do good projects, and it's pretty much as easy as it can get as far as permitting is required.
Thank you, Lauren. Yeah, depending on what the actual work is, there's several things going on. If it's a full culvert replacement, then technically fish passage approval is required from ODFW. So that'd be a nexus for us. If there's just work going on around culverts, it kind of, for whether or not it triggers our fish passage laws, it depends on exactly the amount of work going on. But there's definitely coordination going on and with these different permitting processes. So let's see. Josh, Steve Ireland is saying his sound is very low. I don't know if you can privately work with him on that.
Right, we're exchanging messages right now in the background. We'll try to troubleshoot this during lunchtime if it's not fixed by then.
Thank you. And let's see, Rich, you have a question.
Yeah, you guys covered a lot of ground, so I've got a few comments. First, I'd like to reiterate my experience with Pomeroy Dam. I live at Pomeroy Estates. I can walk over to that dam in about 5 minutes. Anyway, for 25 years, I've been leading salmon viewing hikes at Fork State Park, which is a few hundred yards above Pomeroy. And every year that I've been doing this, I'm amazed that at very low water levels, really low, the Chinook get over that dam and spawn at Forks Park. And also, I have not noticed any fish stacking up below Pomeroy. So they've got a fish passage in there, and those Chinook don't have any trouble getting over it. And the Coho the same, I assume the Coho the same thing. So I'm not opposed to removing that dam, but it's not a fish passage issue for Chinook, and I don't think it's an issue for juveniles either, because the water gets so warm in the summer that there aren't any juveniles moving around in there. There's some juveniles that rear below the dam because of supercritical flow. So I'm going to put this in writing because I think it's a myth that Pomeroy Dam is a blockage or impediment to any fish. It's a myth. And I'll move on to Seats Dam. My experience with Seats Dam is that the steel have no trouble at all getting over that dam. The Chinook generally don't get over it, but there's not, rough and ready. These serpentine streams aren't thought of as being, big Chinook producing factories. So that Pomeroy does, or Seats Dam does block Chinook. And also one thing about Seats Dam is that from snorkeling, it prevents northern pike minnow and shiners from getting that upper watershed. So that upper Rough and Ready Creek doesn't have those alien fish. And if you took that dam out, they would get up there. The third thing, moving on, is I think we need to look at passage and these other things based on conservation priorities. So coho needs to be the overriding issue because they're listed fish, maybe summer steelhead secondarily. And Bear Creek needs to be on the bottom of the list because there's no viable population of coho in Bear Creek. So I think we ought to put our money and efforts in other watersheds if we're prioritizing things and not have Bear Creek be a priority, although it's politically popular. The other thing, I have a lot of experience with stream connectivity and with side channels. I've written up reports and given presentations about springbrooks, which are cold water refugia for coho salmon. And a fundamental error that the agencies and do-gooders make is they want to open up the upstream side of the side channel. Wrong, wrong, wrong. The way to do connectivity is to open up the downstream access so that the fish can move up in there from the downstream end, and then you don't risk having the channel getting blown out by flow coming in the top end. I've seen time and time again where projects have opened up the upstream end of a side channel and the whole thing gets blown out. So, I mean, that's just something you really have to think about when you're doing side channels. Open them up from the bottom end. The fish can get up there, back their way up. They're going to do just fine. Let's see, culverts. The BLM RMP says they're supposed to do fish passage. It's in their RMP. They're supposed to improve fish passage at barrier culverts. They aren't doing it. So what I'm asking ODFW to do is to review their EAs for timber management and look at their log haul roads. And if there's any fish barriers on those log haul roads, let me know and I'll stick it to them. But they are intransigent. They just won't do it. But I don't know if there's barriers on those log haul roads or not. I don't have the time to go check all those culverts. So I don't know, I've given you a bunch of stuff here, but those are the biggies that I have. If you have any questions for me or you want some clarification, you know, I'm open right now to do it.
Okay, thanks, Rich. Did you say that you were going to get those to us in writing too?
Yeah, I'll follow up with writing when, you know, there's gonna be a little, I guess, you know, we have a comment period for this and I'll document those things in writing, but it's a lot easier if you have any questions or clarification to talk to me now rather than having this writing thing. You know, I can, you know, if you think don't think I'm right or something like clarified, I can do that right now.
Well, personally, I don't have the local knowledge to know whether you're right or wrong. The only one that I have a thought on is the passage based on conservation need, where you said coho should be the priority. Absolutely, coho need to be a priority. My main concern with that as a overarching cross-cutting policy, if you will, and for all restoration is we don't want these other species ending up on the ESA list either. So with climate change coming along, we're going to need to be doing restoration work just to keep them where they are. So to me, that might be a policy-based discussion on how you focus your restoration work. But that's my only response there. Certainly we want to get restoration for coho habitat. I'm not sure we want to totally preclude restoration for other species though, until coho get delisted. Dan, I don't know if you or your staff have any comments for Rich.
I guess I would like to talk with Rich a bit more about seed stam. It'd be better for me to brush up a little bit more on rough and ready before we talk. Rich, I know we've talked about Pomeroy. It's my understanding that one of the key issues for fish with Pomeroy is the ditch. That entire area there at the bottomland between Cave Junction and Kirby, what is it, Anderson Creek that comes in? I mean, that's all floodplain. And we've done a lot of projects with step volunteers where we've confirmed juvenile coho, juvenile steelhead swimming upstream into these little tribs in that floodplain area, utilizing that habitat in winter. Anyway, Pomeroy, it's my understanding that that's one of the key issues is winter flows can get into that ditch associated with that dam, are they able to get out? And lastly, I did want to add, because it ties in, I should have chimed in on what Steve Byerland said. So Kelly Slough, if I remember correctly, at the Gold Ray area, I'm with Steve totally. I'm actually very excited to see, I keep waiting to see if the rogue is going to decide to move all over that former Gold Ray area. Right now it wants to move to the south, to river left. I can't wait for the day when it jumps to river right and we get more channel braiding, just thanks to the power of the rogue itself. But there is a cold water refuge that was documented in the post Gold Ray Dam studies in Kelly Slough. And that's one thing that I think meets both what Rich and Steve are saying. I'm with you. I don't think we want to do anything. And we had opportunities to kind of encourage the rogue to flow into Kelly Slough more. We held off. And again, there is a cold water spring. So fish should be able to swim up at the lower end and utilize that Kelly Slough habitat as it is now. I just thought I'd sneak that in there.
Okay, thanks, Stan. Any other questions before we break for lunch?
Hey, this is Steve Burns. I just wanted to add one more thing. Rich Nawa, thanks for those comments and your local knowledge there in the Illinois basin. And I just wanted to kind of mention that it seems like the ditch system at Seats may have a similar situation to Pomeroy, where during high water events, it seemed to me that it would be pretty easy to entrain fish into the ditch system downstream of the dam, and then it would be really challenging to get back out. Just an observation.
Last time I checked, they had a screen in there, but it would get clogged up and they'd have to clean it. But I haven't checked that thing because it's not being used much because the timber company's gone. So people have it right now. They run a risk of losing their water right on that thing. And so, but when it was running, they had a screen in there, so the fish couldn't get down that ditch. They never showed up at the mill.
Well, they have the screen in there, but during high water events, that ditch is entrained by the river. And so fish that are using the margins of the river would end, as the stream came back down, could potentially end up in the ditch.
Yep.
I see Steve's hand is up. Steve, go ahead. Or Steve Berlin.
Steve. Steve, you're still on mute. Steve Byerland, you're still on mute.
I think his phone is unmuted.
Oh.
Steve, you should be able to speak through your phone.
Well, maybe we can continue to work with Steve on the audio access over lunchtime. Steve, we can't hear you. Jot down your thought or question, and we can get back to that.
Well, I think I got it now. Can you hear me?
There we go.
Perfect.
Yep.
Yeah, I didn't unmute it on the screen, just on my phone. Yeah, this goes to Dan's comments and Rich's about off-channel rearing there between Tuville and the old Gold Ray Dam site that is just very ripe for looking at. I think I would really like to see a plan drawn up for that area, using Rich's expertise and Dan and some of the staff, and I'd like to have input, but there's a lot of places in there that can be addressed, and a lot of it has to do with planting large trees, and to hold the banks and to shade that water in there. But there's a lot of things to be done in there. It should be a target area. That's it.
Thanks, Steve. Okay, so why don't we take a break for lunch? We will reconvene at 1 o'clock. Let anybody know if you're having any technical difficulties during this time. We'll try to work them up. Let us know through the chat feature, and we'll try to clean those up. Otherwise, have a good break, and we'll be back on at 1 o'clock with water quality and quantity. Thank you. Chris, you're, no, there we go. Okay, welcome back, everyone. Hope you all had a good break, good lunch. We will be jumping right back into it here with the water quality and quantity, management strategies and actions. These are starting on page 34 of the packet that was sent to you with water quality. And I think Dan will give an overview of the limiting factors associated with this. Dan, are you back on? Can people hear me okay?
Yeah, we can hear you, Tom.
Thanks, Chris. Dan, are you there? You may still be at lunch.
I'm here.
Okay. Were you going to do some slides before the packet gets pulled up?
Yep.
Okay.
All right, so we're going to move into water quality and quantity. Oops. As Tom correctly pointed out, I'm referring back now to introduce this section to the limiting factors that are on table 6 in the packet. So for water quality, ODFW considers water temperature in fresh water to be a primary limiting factor across the board in the interior Rogue, Illinois, Mid-Rogue, Applegate, and Upper Rogue. For water quality and toxics, this is just a possible limiting factor, very specific to Bear Creek. In fact, somebody mentioned Bear Creek earlier, and I think it was Rich and Coho. It does stand out that, generally speaking, Coho and the Rogue are doing much better than they were in the 50s and 1960s. But it's pretty apparent that they're lagging in Bear Creek. So we'll talk more about that. It's not a primary, secondary limiting factor, but it was something worth noting, we thought. The next part, water quality sedimentation. So ODFW considers sedimentation a secondary limiting factor in the Upper Rogue and a possible limiting factor in the Mid-Rogue Applegate. Moving on to water quantity. So for water quantity, low water and reduced freshwater rearing habitat is considered by ODFW to be a primary limiting factor across the board in the interior Rogue, Illinois, Mid-Rogue, Applegate, and Upper Rogue. Flashy and high flows are considered a possible limiting factor for water quantity in the Mid-Rogue, Applegate, and Upper Rogue. And a lot of that's due to impervious surface in urban areas. So that's just a quick rundown of the of this section and how it relates to primary and secondary limiting factors identified in our work to date on this plan. Again, just a couple of quick slides, nothing super extraordinary here. I think all of us on the phone fully get that our native salmonids need cold water in order to thrive. These are photos I took of a day I was out with a step volunteer during the last drought, I think 2015. And it was a hot day. And I can tell you on the left is Bear Creek in the Table Rock Road area, and it was hot. And what we seined up were non-native minnows. Conversely, when we got up to Bear Creek Park on the right, I mean, literally, you get under that canopy and it was like, oh. Well, I can tell you, if people say ah to the cool benefits of that shade, fish are doing the same thing. And sure enough, we collected native fish in that reach of Bear Creek that summer in the middle of the drought. But there's another issue just generally, and it's discussed in the other species section of this plan. I think Chris will be mentioning that a little bit later on. So people have introduced just as many species to the Rogue watershed as were native, if not even a little bit more. But two species have shown the ability to absolutely colonize the Rogue River and tributaries. And they're actually fish that are native to other sections of Oregon. So the first happened in the 1950s, the red-side shiner, pictured here on the left. Red-side shiner are basically ubiquitous now. Interestingly enough, about 30 years later, pike minnow were illegally introduced into a pond in the north part of the district. And if you check ODFW's old monthly reports, the expansion of pike minnow mirrors to a T the description of the expansion of red-side shiners in the monthly reports just 20, 30 years later. In that other species section of our plan, we talk about, in fact, I think we have competition and predation as secondary limiting factors by these exotic minnows as secondary limiting factors in some reaches of the interior Rogue for our native fish. But it's certainly the case that there's research out there that shows emphatically that when stream temperatures are on the warm side, red-side shiners can beat up, if you will, juvenile steelhead for the best habitat in streams. When the stream temperatures are cool, the reverse, the steelhead went out. Just bringing it up because it's what we consider to be the most important way to combat the non-local species that are so prevalent here in the Rogue. The best way to combat that is keeping streams cool by far. Thought I would add a quick photo on sediment. We'll be talking about here in a bit. I mean, we all know that salmon and steelhead lay their eggs deep down in the gravel and rely on flow through the interstitial spaces to keep those eggs alive, along with producing food for salmon and steelhead. Well, take a look at the photo on the right. That is our area. That's Lathrop Creek in the Grants Pass area. And there is nothing growing in that area. I can almost guarantee it. That is inches deep, decomposed granite sediment. I just threw my seine in there just for effect. I've never seen anything quite like it in decades of time working for the agency. I've seen photos of Pre-Forest Practices Act sediment levels in some of the coastal watersheds. That's the nearest closest thing I can envision. So we'll talk about sediment here in the Rogue. It's very specific to specific reaches where granite is part of the watershed, because that granite is easily disturbed and this can happen. We'll talk about that more in a bit. Oh, and I had these slides too. So this is a site, some of the regulatory agencies, and we know it well. This was a site upstream on Lathrop Creek. This actually happened after that photo I took before. So decomposed granite sediment was already a problem in Lathrop Creek. But I think this was one of the developments that happened immediately post the legalization of cannabis. And people were going in a lot of places, just scarifying an area to prep it for production. And in this section of Lathrop Creek, it is this granitic sand substrate, and it did not stay in place when the rains hit. Here's some of the flow coming off, and of course it went right down into the main stem Lathrop Creek, which, by the way, Steelhead use, Pacific lamprey use, Coho use, Lathrop and Vinoy. One of the things that's a little bit of an oddball thing, but it was noticeable down here, and it kind of maybe is a foreshadowing of what we might see more of under a changing climate. So in 2014, 2015, that was the middle of the last of 3-year drought we had. Our rainfall came in primarily 2 big slugs. In the Cascades, it hit in December, and then in the Siskiyou, Rogue Siskiyou section of our watershed, it hit in February. What was interesting is Immigrant Lake, which is a lake that has issues with suspended solids, colloidal materials, it filled up in a hurry with that February flood, and it filled up with muddy water. Well, what stood out later, like weeks, months later, is that as the irrigation district was releasing water from Immigrant, it was releasing that muddy water that never settled in the reservoir pool. This shows the confluence of Immigrant Creek coming out of the dam on the right, and Walker Creek coming in a good Steelhead stream in on the left. And people were noticing it all the way down in Medford, 10, 15, 20 miles downstream. It could be, under climate scenarios, that in areas where we have reservoirs, one issue that could come up is the water coming out of those reservoirs may end up being muddy water for extended periods of time relative to undammed stream reaches. It's just something to think about when it comes to how society might plan for climate change, and some folks who might be pushing for more reservoirs. Lastly, just a quick slide. We'll talk about flashy flows. And if this isn't a flashy flow, I don't know what is. This is the stream gauge on Bear Creek in Medford. And in this rainfall event, you can see that flows jump from 40 CFS almost to 400 in no time at all. Just a clear outcome, clear result of having a lot of impervious surface. So with that, I'm going to try and see if I can open up the actions. We'll get into the actions now. We're at high risk of operator error.
We have confidence in you, Dan.
Okay, I think I'm getting there. Come on, man. Sorry for the scrolling. Okay, let's give this a try. So we're going to get into the management actions we propose to address primary and secondary limiting factors related to water quantity and, quality and quantity. So first and foremost is riparian vegetation. Oops, I got the wrong thing up here. So there's no question that in so many ways, just promoting riparian protection is critical to keeping water cool throughout the watershed. So that's action 4.1. 4.2, we'd like to work with restoration practitioners, watershed councils, and others to improve the efficacy of riparian restoration. And in some of those ways, it's about just encouraging, for instance, the concept of trying to grow forested reaches farther down onto the valley bottom, kind of a contiguous block, as well as encouraging that once planting starts on a particular stream, encouraging folks to work with all willing landowners to finish work before leaving the area, basically maximize the size of that restoration patch. Some of this stuff relates to there's been a lot of work, for instance, done by groups in the Illinois, and the name of the one group escapes me. I think the acronym was IBIG. But when I called them, so they started work in the early 90s when we were going through a similar multi-year drought, big El Nino. What we're experiencing now is very similar to back then. And they started a lot of work with planting and such. I wanted to see, 20 years down the road, what that vegetation looked like. That we should have seen a whole lot of growth and seen a measurable response in photos. But when I contacted the folks over there, the comment was that the pattern of their work was so shotgun oriented that they didn't think it was possible to be able to tell the difference. To the extent we can, I think it's important to try and be able to measure the response of our riparian work through aerial photos and Google Earth now. Action 4.3, flow helps as well as shading to moderate water temperature. And certainly this will be mentioned again here in just a bit. We gladly work with agencies and organizations to purchase or lease water rights for placement in stream. No ifs, ands, or buts. Action 4.4. We do and we will continue to comment on water right applications that have the potential to negatively impact flow and therefore temperature. So that certainly will continue. Action 4.5, this has been mentioned already by Rich and Steve Byerlin, but certainly we think it's important to continue to identify and map cold water refugia to help prioritize protection and restoration. During drought years, we did it again this year, and we got some help from the BLM in just going around the watershed and looking for unusual, collecting photos and water temperatures in places that might be drier than normal, for instance. I think we found an interesting cold water refuge with some subsurface flow where U Creek enters Jump Off Joe Creek. And that was pretty exciting because Jump Off Joe is very much an urban stream. There's also been a forward-looking infrared survey work done on at least sections of the road. And I know the Watershed Council, Chuck Huntington and others have done work on these cold water refuge sites. No question, we want to continue to identify, map, and ensure protection of those sites. Action 4.6, want to work with DEQ on the water quality trading associated with wastewater treatment plants. In part, this was done because the issue with one of the wastewater plants in our area was brought up several times in the stakeholder process. The bottom line is ODFW certainly recommends that we support the idea of riparian planting to mitigate the temperature impacts, both close to the release and farther downstream. But you got to do it right. The existing DEQ models basically prioritize planting on main stem areas like the main stem Rogue River. we think that actually is incorrect, that the planting should be taking place on tributaries where you can actually physically measure and see fish response with cooling associated with shade. We want to keep working with DEQ to make that happen. Then on action 4.7, the last action we have listed here for water temperature, this is definitely an action related specifically to climate change. So climate models don't predict a rosy picture for stream temperatures in the Middle Rogue. No question about that. We think it'd be actually really good. I, in particular, would like to work with City of Grants Pass and partners on a pilot project exploring the use of treated wastewater for either land application or groundwater injection to produce a cold water input to the river. This was an item that was discussed in that mid-2000s rogue climate change workshop I attended. It may not work. I would just certainly like to try a pilot project to see if we could get clean, cool water coming into an area that may be pretty dire here in 40, 50, 80 years down the road, or whatever the time frame is. So those are the actions we're proposing for temperature. Next is on the toxic pollutants thing. And again, this is action 5.1. This isn't considered a primary or secondary limiting factor. It is noticeable, though, that Coho seem to be lagging in Bear Creek compared to Chinook, compared to Steelhead, we've even had some pretty good lamprey counts out of Bear Creek at times. So we have an action recommending that NOAA, encouraging NOAA to investigate the issue of copper and pesticides in the Bear Creek watershed to see if there is something that could be going on, could be combining synergistically to be very negative for especially that threatened species. Next, we have 3 actions related to sediment. Again, we talked about here in the Rogue how it's kind of specific sites where we think the big problem is. Subbasins, stream reaches that flow through granite, that easily erodible, easily disturbed, and if there aren't excellent management practices, that stuff washes off into creeks and is not good for fish. So in action 6.1, we certainly want to work with anybody and everybody to foster the idea of best management practices to reduce that sediment input. This is going to be heavy to Josephine County, some of those urban tribs especially, Lathrop, Vinoy, Allen Creek. There's certainly other areas in Jackson County, some of the summer steelhead stronghold streams with some of the highest spawning densities flow through decomposed granite. We specifically support the BLM in their efforts to minimize road miles, and they have that listed in their water quality assessments and management plans. We applaud that and support that on these subbasins where DG is dominant in the watersheds, specific sites. We also think it's wise to be careful with fuels reduction in the subbasins with DG, just to minimize chronic input. I know a lot of fuels reduction is done to minimize a catastrophic wildfire that could result in a big flop of sediment, but oftentimes fire can do generally good things for fish and wildlife habitat. But we certainly don't want to have repeated entry into a watershed that might minimize result in a lot of chronic input of decomposed granite into the creek. The next action is 6.2. This is about that site that I had the photograph of where there were inches of decomposed granite in Lathrop Creek. I think it would be interesting to do, and I apologize for my use of pilot project a lot, but to do a pilot project where we actually measure that sediment depth while simultaneously working with DEQ, Josephine County Planning, anybody and everybody to do outreach to the landowners upstream, implement actions to minimize that sediment input, and see if we can actually clean up Lathrop Creek, monitor and report on the results. I think it'd be an interesting project. We have some other sites where DG has been a problem. For instance, we have an irrigation diversion that ships water from the Little Applegate over to a trip of Bear Creek. And that ditch, the McDonald ditch, has blown out several times, resulting in, just because of it's just an old earthen ditch. And that results in some sediment plumes and damage in the Little Applegate system. Again, very specific sites, areas flowing through granitic soils. I'm going to skip action 6.3 and section 7 because it's kind of specific to the South Coast. And I'm going to move on to water quantity, if that's okay. So key actions needed to address primary and secondary limiting factors related to water quantity. So 8.1, we want to work with agencies and organizations to, again, purchase or lease water rights to be placed in stream. Now, there was an exciting project in the Upper South Fork Little Butte watershed. And I don't know if Kyle could chime in on that briefly. I believe the lease took place, but I think there was also, it was being purchased in stream. Kyle, I don't know if you could chime in whether that happened, what the status is of that. Jay Duino at TU at the time was leading that effort. Or maybe you could do it by chat. Just an example of a pretty exciting project to get some additional in-stream flow in the South Fork, at least throughout the South Fork down to the lowermost irrigation diversion, where senior water rights would hold play. Action 8.2, we propose to conduct outreach to support that very action in 8.1, is reaching out to water right holders, focus on priority watersheds and opportunities. Opportunities were studied really well in the early 90s with water resources. There was a review of needs, availability, and opportunities. That will help. But we also want to use the LASHEP project, the Little Applegate Stream Enhancement Habitat Enhancement Project, as an example of the benefits associated with in-stream rights. So that project was an Applegate Watershed Council project with multiple partners. I couldn't even begin to list the partners. Really did good work. It got people off of an in-stream diversion and got the irrigators using, I believe, releases from Applegate Reservoir instead. On top of that, it resulted in 2 dams being removed and stream gauge being placed near the mouth. And I don't think there's any question. We don't have data from the last time we had a severe drought in the early 90s, but I have photos, and I don't think there's any doubt that we have more water through this current drought than we had during the drought in the late 80s, early 90s. Just another example of conditions being better for fish now compared to past droughts. Action 8.3, mentioned before, we're going to continue to comment on water right applications that have the potential to negatively affect water quantity. Looks like we have 2 8.3s, kind of in that same vein, identify areas where there's no water available for more rights, for more allocation, and recommend they be removed from appropriation. Action 8.4 is promoting beavers and pond habitat to increase water quantity and in-stream structure as well. there are differences of opinion on this, but ODFW is clear. We think that the key thing is riparian diversity and restoration to foster beavers. That's the most important thing to do, to encourage beavers and dam building beavers. Basically build it and they will come. Secondarily, though, is conducting outreach to help landowners live with beavers. I think we'll talk about this a bit more in the next section, but in our STEP program, Ryan Battleson has hustled on this. He's actually received some grant funding. We propose to have beaver emphasis areas in specific subbasins of the Rogue, like Elk Creek in the Upper Rogue, and want to focus on encouraging and not only beaver presence and beaver abundance, but beaver dams in these specific areas. I can tell you that beavers don't want to play by the rule book. Where we seem to have the most beaver dams is in the Bear Creek watershed, where we have 200,000+ people living. Kind of a challenge that we'll talk about here in a bit. Action 8.5, certainly want to support water conservation and efficiency outreach. I know this happens during drought years. The agencies get together, but we want to double down on this moving on into the future on efforts to benefit fish habitat. Several ways to do that. I know one thing that I've kept pretty good records on my water use at home, but I got to tell you, I would love to know how I compare to others in my community. But you need the data to be able to do that, either a median water use level, monthly level, or average, whatever metric we could get. That's just one little thing we would like to be able to advertise to folks to help individual homeowners see how they're doing, see if they can do more to conserve water. Somewhat related to this, I will mention that there are situations on the road where leaky ditches actually result in more water being diverted than is allowed in the water right, and that's a concern. We certainly support irrigation efficiency improvements, but improvements with fish dollars, that improvement needs to result in a transfer of some saved water in stream. But there is this other issue as well about old canals, leaky canals, and just the combination resulting in more water being diverted than really should be. 8.6, we want to work with forest interests to evaluate ways to increase summer flows through forest management. I want to emphasize this one. So this was a topic as well in that Rogue Climate Change workshop in the mid-2000s. It's a topic again today. Sean Clemens can talk more about it. But we would really like to develop, a pilot project where we look at, work with the owner, federal, private, whatever, maybe both, to look at stand, age, and density and the effects on stream flow. We think this is critical information needed to, again, plan for resilience in the face of climate change. Really want to make that happen. Action 8.7 is promoting citizen science. We talked about citizen involvement briefly way at the beginning. I just want to reiterate that habitat protection is critical, a critical need for citizen involvement. If we can get people interested at all. One example might be, for instance, in Josephine County, we get a lot of, we have the opportunity to comment on a lot of lot splits around the county, a huge number. And all those lot splits, what's their water source? Groundwater. That's a potential concern. And it's something where citizens might want to get involved in reviewing and commenting on land use applications that have an effect on quantity and quality of water here in the watershed. Action 8.8. This is another climate change need. And I know the Corps has looked into this already, but we certainly recommend that the Corps update their fill season rule curves at both reservoirs in the watershed, Applegate and Lost Creek. And this is all about just increasing capacity for flow augmentation in a lot of years, but especially important during drought years. I know this is going to be challenging because who's going to get sued if something goes wrong? The Corps. But this is a no-brainer for climate change planning, and we'd certainly love to see that happen. See some flexibility, and there is some, but yeah, just an update of those fill season rule curves. I should add, Lost Creek, the fill season is January 1 through May, to about May 1st. Applegate is February till about May 1st. Okay, action 8.9. We want to coordinate with the Corps and just ensure that Applegate continues to be managed to meet its fishery obligation. And just for everybody's FYI, that includes flow augmentation in summer to benefit juvenile coho and steelhead rearing in the main stem reaches of the Applegate. So that's a primary focus of ours with that reservoir. Helena Linnell, I believe, Helena sent me an email at lunch asking about, I believe, fish ladders at Applegate and Lost Creek, whether they were ever planned way back in the day. I'll just sneak in there that there was never a plan for a ladder at Lost Creek, but Applegate was actually approved by Congress with a requirement for a fish ladder. It makes me sick to my stomach, but I have the letters in our files here. The Corps later at the time asked to be relieved of that responsibility. They asked both the Fish and Wildlife Service, I believe at the time, and ODFW, and we did finally concur because of the engineering challenges with providing a fish ladder. It's a real shame because there's at least 34 miles of high quality habitat upstream of Applegate Reservoir. Yeah, I can tell you for folks that aren't on our stakeholder team that we've already, ODFW has been doing releases of marked hatchery fish to learn details of how many fish can survive the trip through the reservoir, out the control tower, and going out to sea. And we have confirmed that fish will survive. Winter steelhead will survive that trip and come back as both half pounders and adults. I think it's critical that citizens and all of us collectively look at Applegate for additional fish production upstream, noting as well that Applegate does not currently produce hydropower. And there are proposals to retrofit with hydropower that come fairly regularly. I think we have a real fish opportunity here. Right now, ODFW is just scoping how well fish can survive the trip down to help guide any future decisions on restoring production upstream. Again, another climate change adaptation that we're trying to learn about as we go. Action 8.10, we want to continue to explore opportunities to protect that ambient spring-fed stream flow in Big Butte Creek. If you've ever done a stream survey, even in the South Fork of Big Butte, below the falls, there's a big diversion by the Eagle Point Irrigation District. Dramatic difference in stream flow downstream of that diversion. But it's also the case as you walk, you can see the water flowing out of the hillside. It's amazing the level of spring input into Big Butte, even with Medford tapping a big chunk of that for its water supply. Yeah, just something that especially with the challenges we're facing here in the future, we'd like to explore ways to protect and enhance that spring-fed flow. All right, action 8.11. we'd very much like to work with Water Resources to explore details on groundwater use in the Rogue Basin for effects on stream flow. Another apology, because I'm going to mention a pilot project again. I would very much like to see a pilot project X years, measurements of groundwater use, measurements of stream flow, a reporting of that data, and identification of any changes that might be needed. I can tell you that NOAA and their recovery plan, I think, had at least a couple of entries on groundwater use in the Rogue Basin. We think it's very important. We'd very much like to partner with Water Resources on that effort. Two more. Action 8.12 is working with irrigators on site-specific improvements. And then 8.13, working with districts and partners to minimize risk from some of the ramping issues associated with irrigation flows, as well as the end of season use that can affect fish. So just two quick examples. On Bear Creek, downstream of the lowermost irrigation diversion, there's effectively a reach of Bear Creek that's dewatered. Stream flow returns to Bear Creek several miles downstream because of tributaries, but also because of return flow through some other tributaries, irrigation return flow. But that dewatered reach puts fish at risk, but also fosters the non-local minnows that are so prevalent. And Bear Creek, we have fathead minnows on top of pike minnow and red-side shiners. It may be under scenarios of climate change during droughts, we might want to work with the districts to, maybe it's better not to have any flow in that dewatered reach. I can tell you that we might have recommended that already, but we hesitated after consultation with Stuart Reed because of lamprey that potentially might be present in that dewatered reach and able to survive. So that's a lot of talking, but that's what we have for actions to address water quantity. We have one more section. Here is the issue of water quantity with high and flashy flows. And our response is a proposed, kind of a broadly proposed action of 9.1 with several different aspects. Certainly commenting on removal of fill permits and other land use applications that could affect flashy and the level of flashy and high flows that come about from impervious service. But almost more importantly, we're increasingly seeing that stormwater swales, bioswales and such are being built in the riparian setback to the detriment of riparian vegetation. I've got a lot of concerns about that. I see ODFW recommending nonstop that that on-site stormwater take place outside the riparian setback. I'm not sure we're going to get support from cities. Just something we want to make sure you folks are aware of. There's one being built right now in Ashland, right along Bear Creek, that causes concern for me. One other thing on riparian setbacks is that very typically, riparian vegetation is managed through Oregon's land use law. Land use law is implemented by cities and counties. ODFW has zero authority on riparian vegetation. I can't tell anybody they can't cut a tree. I don't have any regulatory authority. I can ask, and we ask all the time. But cities typically have a waiver, or not a waiver, a thing where development can be allowed in the outer half of the setback area if planting is done to provide basically equal or better protection. I'm increasingly becoming convinced that we should recommend against that because of the issues that might be coming about with greater winter storms and flood damage. Again, not sure how well that's going to be taken by landowners and cities. Just want to make sure you folks are aware of that, and we're looking for feedback as well. Some cities have stream cleaning programs. We see that, I think, in both Central Point and Medford, where crews go in and remove all wood. We would certainly like to tweak that and see if we can get some large wood to remain in place that would be a little more resilient, not cause problems, but actually provide some fish habitat in these urban tribs. And lastly, again, that issue of these streams, these urban streams, Bear Creek, potentially Jump Off Joe, are subject to flashier responses during storms because of impervious surface. But little fish will do okay if they can go up into little tribs that are watered during these storms as well. The problem is barriers block their entry a lot of the time. And again, that linear connectivity, that surrogate for floodplain connectivity, can be provided in these urban areas, especially if we improve passage on the tribs. That is a lot of talking, but I think that ends this module. So I think we open it up for questions. And Tom, can I send this back to you?
You can. Thank you, Dan. And so, yeah, let's have some discussion about what Dan has just presented on water quality and quantity. Questions, thoughts? Rich, you have your hand up first here. You are still on mute, Rich. There we go.
I did it.
There you go.
Okay. Well, I'm getting a little weary, but here goes. There's a real pressing issue right now with Ashland Creek because of potential toxic runoff from urban areas because of the fire. And this is instructive of why Bear Creek can't produce coho, urban runoff in the storm drains. So I'm hoping ODF&W is out there with DEQ getting sandbags and whatever else they got around every storm drain that was affected by the fire, where you're going to get ash runoff. And what happens is the first big rainfall we get, the fish will come up and they'll get a dose of toxic ash. And so I'm concerned about that. I guess people are on it, but I think there needs to be some oversight there, because we aren't going to get it. We got a window now to prepare for it, but once that big rain hits, we'll find out how good a job we did. The other thing is the same thing happens without toxic ash. There's urban runoff into Bear Creek from these rooftops, roads, whatever. And it's NOAA published a paper about 10 years ago, and essentially there's no coho in Seattle streams because of this urban runoff. And they have models telling you how bad this is. So like what I'm saying is coho is probably a losing proposition in urbanized areas. And I'd like to lead that into industrial forest lands. So industrial forest lands commingled with BLM is where we're going to get the biggest bang for our buck. And we need to emphasize the issue of chronic sediment rather than episodic sediment like you got in Lathrop Creek. So chronic sediment off of roads, industrialized watersheds is the nut to crack. There are techniques to reduce sediment from roads by disconnecting the road from the stream without eliminating the road. And there's quite a bit of research supporting this. Kara Anloff did a major study on Oregon coastal streams documenting high sedimentation. And there's another study about road densities causing sedimentation. And one thing that isn't quite well known is the place where you see more coho is where there's very low road density. So in other words, reducing sediment in high road density areas, say, well, we're going to go from 5 to 4, probably isn't going to help the coho. But if you have a small watershed that has maybe 2 or 3 miles per square mile, and you get it down below 1, then you can have an effect. So it's these tiny watersheds, smaller coho watersheds in industrial forest lands where we can get the biggest bang for the buck. And I mean, the industrial forest lands just dwarf any kind of impact that urban areas have on our fish. So I just want to emphasize that. And also the issue of water flow. There's been 3 published papers that demonstrate unequivocally that the conversion of old growth mature forests to young growing plantations has significantly reduced the flow in these small tribs, 40–50%. And the agencies, BLM and the ODF, are in denial on this. And but I think we need to take a look at it and look at those papers. In other words, we need to get mature forests growing on our headwater streams. I'm talking about trees that are 120 years or older, and that could possibly restore the flows that we had historically in those watersheds. But right now we're running at a deficit, and it's exacerbating any impacts from climate change. Oh boy, I don't know. I think those are the biggest ones I got, and I'll write this stuff up when I send you the information. But we need to be looking at the industrial forest lands and the intermingled lands, and ag and urban are important, but I really think the fish issue is going to be in the upper watersheds where forestry is. The last thing is, I mean, yeah, DG is bad, but there's sediment issues everywhere. Anywhere you have high road density, you're going to have elevated sediment in your stream, and the Coho are going to be hurt, and they seem to be pretty sensitive to elevated sediment. So you got any questions for me after that? I talked a lot. If you have any questions, ask me now, because I'll write this up in a comment letter as well.
Okay, we appreciate it. Yeah, I was taking notes. I don't have any specific questions. Maybe just one quick response. I know Dan and his staff are certainly involved in the toxic runoff question around the wildfires. So we certainly share that concern. Dan, I don't know if you have anything else to add or questions of Rich.
Two things. I just thought I'd mention that actually it's the wildfire, urban wildfire issue has actually been taking a lot of workload here and has caused me not to be able to return some calls, including to Kirk Blaine, which I don't know if he's on this call, but anyway, we are definitely involved, and a lot of people are involved. The fish interests align really nicely with the Rogue Drinking Water Partnership. I just hope we're just going to do our best to keep toxics out, especially with this first flush. But more importantly, Rich, I guess we may have to agree to disagree. We don't believe that a broad scale approach at addressing road densities is warranted in the Rogue watershed. We think there are specific sites where sediment is an issue, but that it's not a broad scale issue in the watershed.
Okay, thank you. Looks like Steve Byerlin has a question or comment. Steve, go ahead.
Yes, I sent a chat, but probably a decade or longer ago, there was a meeting of the irrigators, irrigation districts and towns in Medford, and I think it was looking ahead 50 years to what they needed for water usage or withdrawal. And at that meeting, speaking with the Medford Water District, they, gave indication, after being asked about it, that they would consider not taking water from Big Butte Springs if they got additional water at Duff treatment plant at Tuville, and I don't know if that was ever followed through or not. I was invited to the first meeting, but wasn't invited to any meetings after that. So I don't know what that meant, whether they had meetings after that or not, but Dan was there, and Tom Satterwhite, quite a crowd, but that would be a way to help get 25 to 50 cubic feet a second year round into Big Butte Creek. Even if the arrangement was only for part of the year, it would be a big help. But just something to think about, following up on that and seeing if that could be arranged.
Okay, thanks, Steve. I do see you have that in the comments for people. Anybody else? We will be capturing the comments that are put out there, so we will have those on hand. Are there any other questions or comments for Dan on the water quality and quantity section? Okay, so Dan, can you take us back into the packet on the in-stream physical habitat, which is kind of what's between the banks of the stream, the physical structures. And we are on page 37 of the packet, and Dan's gonna do some slides before we start going through the actions again.
So I think I'm unmuted.
You're good. Yep, we can hear you.
So this will be much quicker. So in-stream physical habitat, in-stream structure and complexity is considered a possible limiting factor across the board in the interior rogue, Illinois, Mid-Rogue, Applegate, and Upper Rogue. I don't know that I need to show a lot of slides, just have a couple here. But a little bit of a twist on large wood. One thing we'll talk about here in a bit is the issue of large wood in the main stem rogue and Applegate that is quite often removed because of navigation concerns. So this is a big cottonwood that fell near the town of Applegate on the Applegate River. ODFW has met with the Marine Board and the Marine Patrol, the deputies here in the rogue. They have a particular mandate. In this case, they actually came out and moved the cottonwood closer to shore to reduce the navigation hazard, and it was a win-win for everybody. That's not always the case. We do lose a fair amount of wood because of the navigation concern. A little bit lesser extent, but another issue altogether. Certainly in our spring Chinook or our Chinook plans, conservation plans, we talk about fostering mature floodplain habitat. So this is the Gold Hill Beach Park. The area right here is a floodway or floodplain channel with a lot of large wood in it. The problem is that a lot of folks in Gold Hill want to do quite a bit of cleanup out here, and cleanup includes getting rid of all that wood. Yeah, in the name of cleaning up the park, we're trying to work with Gold Hill to make sure, maybe some areas, certainly small wood pieces are cleaned up, but large wood, especially in this floodway channel, is left intact, as well as these maturing floodplain trees to continue to provide habitat for years to come. Beavers, an obvious way to provide in-stream structure. I already mentioned that, talked about beavers in the last talk. This is a photo of a dam on Ashland Creek, and if Siobhan Haynes at the Water Resources Department is on the line, I'm sure he might be saying a few expletives about this beaver dam. Anyway, there seems to be a thought that there aren't many, or a lot of people don't realize that we do have a good number of beavers here in the watershed and good numbers of beaver dams, not as many as we need. But again, I think there are clear ways ODFW plans to proceed on encouraging beavers and beaver dams through riparian restoration, making sure beaver food is present, and on helping people learn to live with beavers. Again, Bear Creek seems to be a beaver hotspot. They like it there. It's just that 200,000 people don't necessarily like beavers there. Ashland so far is living with beavers in Lower Ashland Creek. Medford's had a harder time living with beavers on some of their tributaries. Thought I'd mention just one other quick thing on gravel placement because we include it. Oh, what did I do? So on Big Butte and Big Butte, there's a whole lot of reasons why we did this that are very specific to the geomorphology of Big Butte. The bottom line is for Spring Chinook, we did quite a project Jay DeWino did on my staff to place spawning gravel in Big Butte where there wasn't any. But not only that, to evaluate whether that rock persisted. So we placed quite a bit of gravel. Spring Chinook spawned on it, Coho spawned on it, but he also pit tagged the rocks. And you can see the data here in the upper right. Through a pretty darn good storm in 2013, 2014, very little movement. We were really gratified about that, and we plan to do a lot more of gravel work in main stem Big Butte. Again, it's a very site-specific thing related to site-specific conditions in this creek. So with that, move into a couple of actions. Oops. Okay, does everybody see that?
Yep, we can see it, Dan.
Okay, so just we have what, 7 or 8 different actions proposed for in-stream structure and stream channel complexity. So action 10.1 is promoting riparian vegetation, again, as the primary way to grow, if you will, more in-stream structure. As those trees mature, as they die, they provide value as standing snags and a whole lot of value in streams when they fall. We talked about already on action 10.2 about working with people who do riparian restoration to ways to improve, we think, the scope and effectiveness of that restoration. Action 10.3, ODFW encourages when large wood projects are done that they meet the ODFW size criteria more often than not, rather than doing more expensive engineered log jams or undersized wood installed into banks and such. Action 10.4, we support implementing actions to increase structure and complexity identified in the Elk River Strategic Action Plan for Coho, but also the Upper Rogue Coho Strategic Action Plan. Action 10.5, now this is not to the detriment of shade. There's no question that for riparian restoration, we still have a need for just even the shade component and benefits of riparian restoration, as well as riparian diversity for wildlife and beavers and the whole health of riparian stands. But there's also a lot of areas where adding a ponderosa pine component will pay off down the road. I would definitely like to see, for instance, on all 20 plus miles of the Bear Creek Greenway, that we encourage ponderosa pine to be planted, and again, restoring that component to Bear Creek. I should add, for people who live in Bear Creek, historian Jeff Leland actually has old photos that seem to show he's pretty convinced that pine were a much bigger riparian component than we realized back in the day, at least on that watershed. Action 10.6 is gets at what I was talking about in some of those slides, is working with Marine Board deputies and river users. We kind of need guides and other river rafting companies to chime in on this and get involved to identify areas where large woody debris can remain and not be removed as navigation hazards. Sure love to come up with ways to do that. I can tell you that when we met with the Marine Board, we actually met as well. Blue Ridge Timber attended that meeting. There may be opportunities in individual trees that would be important enough, like a large ponderosa pine that falls in, where we might try and scrape up the money to pull it to the side so that it continues to be a habitat feature as well as not being a risk of being a strainer for raptors. Something that I wish we'd hear more from river guides on this issue. Action 10.7, we absolutely support all kinds of restoration in Elk Creek on the Upper Rogue. We've already talked about this today. I won't go into details. There's all kinds of work that can be done. One thing I didn't mention before is I think it's critical to add pea pine and black oak in that valley bottom. Again, growing habitat for the future. Steve Byerlin has brought up culverts, and Steve, we may have to talk about that offline maybe, but I thought there was just the one culvert that was a sizable barrier, but fish can pass when conditions are good. But I thought there was quite a bit of wood placed below that might have reduced the jump. Anyway, sounds like maybe we should talk offline on that for more details. The last action, 10.8, was I mentioned before, we want to continue to place spawning gravel as well as large wood and boulders in Big Butte. We think we get spring Chinook benefits. That's the one stream that spring Chinook use for spawning on a regular basis, annual basis. It'll benefit Coho as well. And I think it's an action item in the Upper Rogues Coho Strategic Action Plan. I think with that, my presentation is done.
Your presentation may be done, but you aren't.
Oh.
So any questions, comments, discussion for the in-stream physical habitat pieces? For Dan?
Hey, Rich.
Rich?
Yeah, well, I was letting anybody else jump in ahead of me. I guess not. But I've got one thing that kind of was left over from my previous discussion. Again, industrial forest lands and commingled BLM. I think if you do any assessment, you'll see that's where the bulk of the coho are. And I want to bring up the issue of no-cut buffers. So BLM in 2016 did a revamp of their land management plan, and they consulted with National Marine Fisheries Service. And they ended up with 120-foot no-cut on perennial and fish streams. Let that sink in, 120-foot no-cut. So what does Oregon Forest Practices Act have? 20 feet. So the Oregon Forest Practices Act guarantees there will be no large wood in those industrial forest streams because they'll cut the trees before they get to be any size. The 20-foot buffer isn't going to provide you enough wood. So we need to deal with that discrepancy. The science wants 120 feet no cut, and Oregon Forest Practices Act is doing 20 on the smaller streams. I think it's more on the fish bearing streams, but I don't have that data. But we got to do something about that Oregon Forest Practices Act. It's got to get up to speed if we want wood and shade on our streams. That's all I got.
Okay, thanks, Rich. Steve Byerlin?
Yes, I think Rich has got a good point there. I think we need to look at spawning channels. We've got in the Elk Creek Valley there, up Elk Creek, we've got that land owned by the Corps of Engineers, where they basically do denutritive trees and cause damage in there. We're going to build a dam. Maybe creating a spawning channel in there that might be pretty large. That would be helpful. My understanding it only takes 3 to 5 CFS to water a spawning channel, and another one in the lower part of Big Butte Creek. To give those springers, coho, and steelhead spawn in there quite heavily too. Some place to go. And but I think might give a kick in the pants to wild fish if we could consider doing that. Done.
Steve, can I ask you a question about what you mean by spawning channels? I mean, when you say that, I have an idea in my head. I just want to make sure we're thinking the same thing. I think of possibly off-channel built structures, maybe concrete with spawning gravel in them that are watered up. Is that what you're thinking, or are you just thinking more focused gravel placement projects?
No, I'm thinking of a multiple S's that come off the main channel, maybe with a head gate, so the water can be controlled. But if it flooded, it would go right over top of them, you know, and they would be more natural. They'd be planted with trees, and it'd be a series of S's, maybe 30 or 40 of them tightly laid together, would give you a lot of footage, you know, to lay the gravel in, and different speeds of current going through there. And but definitely planted with trees, and very natural looking, other than the shape. But yeah, no concrete. I'm not thinking anything like that.
Okay, thanks for clarifying that. Any other questions, comments on the in-stream physical habitat section?
Tom, I just want to point out there are a couple of comments in the chat section.
Okay.
One of them is Stacy just offering contact information for follow-up discussions, conversations.
Okay, great. Thank you, Josh. Okay, well, not seeing any other questions. We are through the, through the third module on the agenda early, and we are a little bit past our scheduled break time. So why don't we take, actually, maybe I should ask folks, we could take a 10-minute break now, or we can just power through and finish up here. The thing after the break would be a question comment session, basically opening it up for any sort of questions, comments on what we've talked about, or anything more general related to habitat. Then a quick little overview of the next steps, and we'd be done. Or do you want to power through, or do people want to take a quick 10-minute break? And we can do that by maybe those who want to power through can raise their hands on there. Seeing a number of those pop up. Okay, I don't see a majority, so sorry to those who raised their hand, but we're going to take a quick break here. Why don't we come back at, why don't we take a 7-minute break and come back at 2:20? Thank you. Okay, why don't we get started again? So we are in a general question comment period. So anything habitat related up for discussion, thoughts, comments? Happy to hear them.
I see a hand up. Maynard?
Maynard, go ahead.
Okay, we heard noise from your phone. There we go.
We can see the top of your head on the video, Maynard.
Can you hear me?
Now we can hear you.
All right, great. Finally figured it out. Yeah, I think it was Rich that put the concern out for the ash in all the cities where the fire was. Well, all those cities have stormwater programs that, you know, I'm sure that once they get through the emergency, they'll start working on trying to prevent that ash from going into, or at least they're required to by DEQ. It's called the Phase 2 program. So they should take care of that. If not, then they should be, you know, it should be worked on. I'm sure most of those cities that would have that problem have Rogue Valley Sewer Services, you know, taking care of that. So that's my comment. Okay?
Thanks, Maynard.
You're welcome.
Jenny?
Hi, I actually have a question, clarification question for Dan, but I guess since I'm here, I'll just say that, yes, we have managed the area. I'm the manager of the stormwater area in those areas that burned, and we are actively protecting all of them right now for the runoff that we anticipate coming. So the stormwater system is being actively protected, but if you have specific concerns, you can email me and I can answer your questions. But Dan, I was wondering about in part 5.1, where you talk about having NOAA do an investigation on copper and pesticides in Bear Creek. There is an active pesticide stewardship monitoring program in Bear Creek that's been going on since 2014, where we're monitoring for pesticides there. So I was wondering if you were interested in I guess in the combined effects of copper and pesticides specifically, if that's what you were actually asking NOAA for, or if you were asking for studies independently into copper and independently into pesticides. There is the copper ligand model in the Willamette area where they've got a TMDL for copper. So I know there's information available on that.
Can I respond by saying yes? Yeah, I haven't put a whole lot of thought into it other than it's been something nagging at our employees here, of just result of acknowledging that Coho are present, but appear to be lagging in Bear Creek, and what might be causing that compared to other nearby watersheds.
Okay.
So that might be something ODFW could talk with NOAA more and check back in with you to see how best to proceed.
Okay.
Okay, so I'll make a note to kind of think about refining that action after a little bit of coordination. Thank you. Any other questions, comments?
Hi, Clint. I see that you have a question posted in the chat. For those watching the meeting on YouTube, if you don't mind elaborating that by turning on your mic.
Yeah, sure.
Thank you.
Yeah, this is Clint with the Jackson Soil and Water Conservation District. And my question was basically about the Wildlife Habitat Conservation and Management Program. Not know what that is. This program that effectively provides tax incentives for private landowners who voluntarily conserve or preserve wildlife habitat on their lands. I've always sort of associated it with something similar to the farm and forest tax incentives that the counties place on properties that are farming or are doing forestry operations. I've done a little bit of talking with other SWCDs, and the feedback that I've gotten from this is that that program is essentially an unfunded mandate from the Oregon legislature. So ODF&W has this program, but has never had the staff to really support it as a program. And I'm just wondering if down here in Southwest Oregon, we feel that that would be a program, like if ODF&W was actually staffed appropriately to implement that program. Is that something that here down in Southwest Oregon, do we feel like that would be an effective way of improving fish habitat and preserving water quality?
Hey, Clint, this is Dan Van Dyke. So I just looked up quickly in the folder from dating to when we were working with you on the riparian tax incentive program. And according to my notes, Josephine County, Curry County, Jackson County opted out of this, the WHCMP. So we can double check this for you, but it's not a possibility in our area.
Yeah, that's another part of the question is if my question is just if the counties adopted that and said that they would be supportive of that program, do you guys as fish biologists working for ODF&W, do you feel like that has been successful in other areas? Would it be as successful down here?
Clint, I have to confess my ignorance. Tom, do you know?
Yeah, I'm guessing Dan doesn't have any experience with it since the counties have opted out. I am not real familiar with that program. I'm a little bit more familiar with the riparian tax incentive, but not much. Both of those programs are managed out of our wildlife division. And I haven't gotten an update on kind of how those programs are doing. So we would have to look into that a little bit more to see if we should put a recommendation in here that, we work with the counties. Sean, do you have something to add on that?
Just a little in talking with Jeff Beckler and others in the valley here. I think part of the problem is the burden on ODFW for long-term monitoring of these sites to make sure that the actions are consistent with the incentives they're getting. We've got a backlog of monitoring that needs to be done and just no staff to do it. So it's difficult to implement.
Yeah, and in fairness, what we're finding as conservationists out on the ground working with private landowners, we're seeing essentially the same thing with the farm and forestry operations as well, except that there really is no oversight in those programs. So there are a number of landowners that are quote unquote farming, but they're farming for the purposes of the tax incentive. And so again, I'm sure the wildlife incentive can be prone to the same sort of I don't know if abuse is too strong of a word, but sort of that manipulation of the purpose of that tax incentive. And in talking with these landowners, a number of them actually will tell us that I would love to preserve my land for wildlife habitat, but the county isn't going to incentivize me for that. They are going to incentivize me to plow my field and plant hay or whatever. And so that's why I'm kind of bringing this up, is I am hearing from some landowners that they would like to see more incentives for people to do some private work on their land. But again, the county doesn't want to incentivize that at this time. So I was just curious what your guys' experience was with it. So
yeah, I appreciate those thoughts. Good. We'll think about ways to possibly integrate that into the actions for this plan. Thank you.
I saw two
Yeah.
hands up early. Oh, sorry. Go ahead.
Yeah, just one more thing real quick. So there are a lot of other SWCDs, particularly up in the Willamette, that have been working on this issue. So if that is something that ODF&W wants to take up there, let me know and I can help you kind of connect with some of these other people that have already been doing a lot of this work. So.
Okay, thank you.
I saw Laura's hand up earlier. I'm not sure if she intentionally lowered her hand. Laura, we're good to skip you, or does you have a question?
That was just an accident. Sorry about that.
Okay, no worries. So I see Steve's hand up.
Yep. Steve?
Yeah, on that last part about the tax incentive, I wonder if these were presented to the county on a case by case rather than a broad brush, that they might be more willing to do it. Also, I wonder if the tax incentive might relate to barrier removal on private property, that if a landowner removes this barrier, that he might get a tax benefit for X number of years or whatever, but try to work something out with that if it fits the program.
Good suggestions. Thanks, Steve. We can look into kind of what the sideboards are on those programs, and whether those ideas fit in. Any other thoughts, comments? Things like this that we're missing in here? Okay. Well, with that, then I am going to move on to the next steps. We talked briefly about this in the beginning when I went over the plan development overview, but just to get into a little bit more detail on them. So we're in the habitat work group section. We've presented the ideas we have in terms of habitat management, strategies and actions. We've gotten a lot of good feedback yesterday and today. We'll take that feedback and absorb it and make some modifications as needed. We'll be also taking written comments from you for the next 2 weeks through October 9th. The details of this are in the news release that went out. If you saw that from the agency, that's also available on our website. But we realize giving feedback, in this format or in a shorter period of time from when you got the packets might not work. So there's a couple extra weeks here through October 9th where we're happy to take any additional feedback. Chris just reminded me I skipped something on the agenda, and I'll go back to that in a second. Yeah, I totally skipped that. Anyway, I'll finish this, then we'll go back to talking about the other management categories. But through October 9th, we're taking those comments at the email address that we've set up for all of the plan comments throughout the entire development process, and that is odfw.rsp.comments@state.or.us. If you need any more of those details, you can, contact someone in ODFW that's on this call, or we can get you those details. But we're taking comments through October 9th at that email address. If you have anything else that that didn't get out today. Then the next piece in terms of steps is we'll be taking that information and feedback, and after we have additional meetings with tribes and NOAA fisheries, we'll be developing the first full draft of the plan. which we hope to get out by the end of the year. And then you're going to see everything all together in a written format and have time to get a first cut at comments on that before it goes out to public review or goes to the commission or anything. So those who have helped us build it are getting that look around the end of this year for additional comments as you see it all together. And then I talked about the additional drafts we develop before taking it to the commission in hopefully April and June of next year. Again, you'll have steps along the way to provide additional comment. Let's see, for those, one last comment on next steps. For those on this call that we haven't gotten your email address yet, there may be some that didn't get the Zoom meeting invite directly on email and it was forwarded to you. If that is the case, you'll need to send us your email address to get that draft plan for review if you're interested in that. And you can send that to that email address I mentioned, and kind of note the username you were using in these meetings, and we'll get you on that list as well. So with that, I'm gonna go back to the agenda item I totally skipped. We wanted to give a little bit of context on the other management categories we've been talking about. Today we focused on habitat, like Chris and others have mentioned earlier in the meeting. We've also focused on other management categories with the stakeholder group that we've been working with. And Chris is just going to go and give us an overview of what the kind of where we are in those management categories at a fairly high level. So Chris, take it away, and thanks for that reminder.
No problem. Let's see here. I'm going to pull up another presentation, and I will, like Tom said, I'll try to keep this high level and short. I know this is a long day for everyone to be on a call. So, and I'm sorry I disappeared earlier. If I disappear again, you can blame my internet service provider. Hopefully I'll make it through this presentation. Over the course of the last 6 months, we've been working with a stakeholder group on other management strategies and actions, or other categories of management strategy of actions besides habitat. And so we had 6 sets of meetings with stakeholder groups from the South Coast and Rogue to discuss a variety of other management issues. And some of these were related to, well, the habitat management strategy and actions are the ones that address most of our primary and secondary limiting factors. But there were some limiting factors, especially related to other species, that we addressed with the stakeholders, and then a variety of other management issues that were identified with that group, and we had identified as an agency. And we organized these into categories that I'll go through right now and just give a high-level overview of kind of the main outcomes of those meetings. We're in the process of putting together a stakeholder process report that would provide much more detail about those, that will be available soon, before the draft plan is finished, that you could have a chance to really dig in and see those some insight into those discussions and what the outcomes were. So the first one was other species, and as Dan has talked about quite a bit today, the main concern here in our limiting factors anyway is with non-native minnows that have been introduced into the Rogue and into Hunter Creek on the South Coast, and the way that they compete or prey on native plant species and other native species. And so we have identified some actions with the stakeholder groups to both keep an eye on and monitor where those non-native minnows are at, and also try to reduce their abundance where it's possible to do so, and do some pilot projects to look into that. The other species section also, some of the actions were around continuing our monitoring of fish-eating birds and marine mammals, to see what their effects are and if we need to take a different management approach. And then also to roll all this into a more science approach for all of these species that prey or compete with our plant species, to understand their impacts and make appropriate management decisions based on that. So we've got quite a bit of monitoring that's going on around these other species that's not directly related to our fish programs or our district fish biologists, but our agency programs on our wildlife side or other district staff. So we have quite a bit of monitoring for these other species, and a lot of the outcomes of these discussions was about kind of trying to tie all those pieces together better to understand the impacts of these various species on salmon and steelhead in the Rogue and on the coastal basins. The second category was around hatcheries. And here we identified some management targets as far as for the hatchery programs we do have in these basins. Both targets for how many fish we'd like to see returning and the performance of those programs, but also important limits on how many hatchery fish we want to see out on the spawning grounds. And this is an important part of planning for climate change. And I think it's something that Rich brought up earlier in some of that discussion with Sean around making sure that we don't have a lot of hatchery fish out spawning on with wild fish. And that's an important part of maintaining both the diversity of these wild populations and their adaptive capacity, and making sure the hatchery fish aren't interfering with that. And right now, we feel like the hatchery programs we have in the Rogue Basin are performing well that way, and we have some additional actions to make sure that's the case in terms of monitoring. And then we also identified some release strategies that are going to be hopefully improving angling. So a lot of the actions that come out of the stakeholder group were not just on the conservation side, but also the utilization side, making sure we're maximizing opportunities for anglers and improving fishing. So we have identified some actions around that with our hatchery programs. Let's see. The third category is fishing. And this was a real central piece of the stakeholder group conversations, especially the conversation around wild winter steelhead fisheries and harvest, which is an important issue in this plan overall. And so the outcomes of our stakeholder meetings have really been around improving our data collection around how many fish are being caught. And so we've talked about and reached consensus on some ideas around new authorizations to track and record wild winter steelhead harvest by anglers. Also implementing additional creel surveys to really get a handle on where fish are being caught and how many. And then also really beefing up our monitoring programs so we have a better sense of how many fish are returning and what our harvest rates are, and making sure harvest rates remain low in these basins with the regulations that we implement. Again, to protect these fish moving into the future, so they have the capacity to deal with changes, and we're not having undue influence on any life history type or stage, or reducing their abundance to a level where it's going to affect their ability to adapt to climate change. We've also talked about and agreed to some thresholds below which we would really scale back fishing. So that's been an important part of that conversation too, especially thinking about the future and if we had directional change in the capacity, in the kind of productivity of these systems, that we would have to scale back fishing appropriately to make sure we met the conservation needs. And we didn't make many changes overall in other species, plant species. With fishing, just in general, we've kind of agreed that where we're at with those, in general, we don't have any directed harvest on coho or summer steelhead. And the cutthroat trout fisheries were also felt like we were in a good place on those. So we didn't make a lot of changes on those with that group. Research and monitoring has been a real important topic of discussion. And so, especially around the winter steelhead piece, but just in general, there's a lot of needs for research and monitoring in this area. And with that group, we identified some priorities, and we're going to continue to do some of our core monitoring work, like the Huntley Park seining that you can see on the left-hand side there, and our snorkel surveys that are real important for tracking juvenile salmon abundance. And then we're also discussed and proposed increasing the amount of spawning surveys we're going to be doing out there to keep track of adult fish. So these are kind of the in the field part of research and monitoring. We also have a lot of work that needs to be done on the research side to understand the genetic structure of these populations in the rogue and elsewhere, and also and that relates both to population structure and our monitoring and how we're able to get population specific information with some of our monitoring that happens in the lower rogue, but also to understand some of the life history diversity and even how that affects how we collect fish in our hatchery programs and things like that. So there's a lot of work to be done on the genetic side. Unfortunately, we're going to have to find some money to make that work happen, but it's important that that's stuff is a priority. And I guess finally, I'd say that we talked about it earlier, but we've also discussed with that group the need for more temperature and flow monitoring, and kind of making sure that we have that information to track and manage with in the future. So that was the research and monitoring portion. For outreach and enforcement is the next category. We had actually a lot of actions identified under this. A lot of them are about the way we communicate with the public and collect both through our website and a lot of other means about what's going on in the rogue and elsewhere in this planning area. And then also how we collect information from anglers. We developed an angler survey as part of the planning process that we hope to keep implementing in the future to really understand angler practices and needs and preferences. And then also some outreach programs on the lower rogue and the Rogue Bay fishery to make sure that when folks are, when those fall Chinook fisheries are happening, that fish handling isn't having a negative impact on coho as they move through that system. So really trying to, several different actions to reduce indirect mortality of coho as they move through the Rogue Bay fishery. And then on the enforcement side, some more coordination work with Oregon State Police and ODF&W, and also encouraging the general public to report and make sure that the kind of social aspects of fisheries are being taken care of from an enforcement side. And finally, the last piece was facilities. And this encompasses kind of our needs for, and the actions that were identified, encompass our needs for upgrades and improvements at our hatcheries, and also off-site stations where we might be doing acclimation or that has to do with our release strategies. And then angler access and opportunity and the ability for folks to access the river through boat ramps and other public access points. So those are the main categories that we discussed. I know that was pretty quick, but if we have any questions, I think we could do a quick answer any questions that folks have about those, what we've discussed in those categories.
Any questions for Chris? Okay, well, with that, we will wrap up here. Thank you very much for participating. Appreciate you taking the time and interest to help us develop this plan and also sit through this virtual meeting. Again, if you have any further comments, please get them to us. So with that, thank you very much and have a good rest of the day. And Josh, thanks for all your help too.
Thank you. All right, I'm gonna go ahead and close the Zoom meeting. Chris and Tom, I'll follow up with an email with the summary.
Okay.
Great, thanks.
All right, thanks so much.
Sounds good. Thanks, Josh.
Right, take care. Yep.